Good morning, everyone. Welcome back to Rust Week, the second day. Good morning. That's the spirit. Fantastic. All right, I guess we should introduce ourselves. My name is Stefan. I was here yesterday. I did a meetup, Rust Linz, and moderated Eurorust, and the fine folks from Rust Week asked me to moderate today as well. So we're going to spend the day together.
And I'm Matthias. I'm from Germany. I do the Rust in Production podcast, and I'm a trainer at Corrode.
All right, so first a couple of housekeeping rules, a couple of information for you. If you have any question related to anything, please contact the organizers in the yellow shirts. You've seen them around. They are basically everywhere. They have a yellow shirt with a party fairies in the back, so this is the sign you need to look out for. If you have any need, like issues with accessibility or anything, go ask them.
And also remember that we have a code of conduct that is true for the main track, but also the on-conference. Make sure to abide to that.
All right. For the agenda, this here will be today the main track. In Cinema 11, so the room next door, you're going to have the deep dive track. And in room number 9, where the industry track was, is the Rust project track, where Rust project people talk to Rust project people. But the track is free for everybody, so if you want to eavesdrop, feel free to join them. Also, the GoSim finalists who presented yesterday are downstairs on the mezzanine floor. This is the little floor within the floor in the reception area. And don't forget that there will be some social gathering at the end of the day where we're going to have drinks, have a chat downstairs.
Also, if you haven't noticed yet, there is a Wi-Fi code on your badge. It should be on the back side of your badge.
Breaking news, that's just in, so it's even handwritten in my notes. There's a MakePad mixed reality programming just on the opposite of this room. So you go outside and you can do some creative stuff with Rust.
And by the way, probably all of you know, but there is a Rust event, the anniversary of Rust 1.0, which was like 10 years ago, which is insane. And you can still get the celebration tickets. All the information is on the website.
All right, and with that, we go to our first speaker. So it's a pleasure for me to introduce Miguel Ojeda. I hope I did pronounce it right, yeah? Who is the person who started the Rust for Linux project. And the project is now, I guess, 5 to 6 years old and has come a long, long way. I remember when Miguel was at our online meetup at Rust Linz showing the first steps into that direction. He's now set on the ISOC committee. He's a staff member at CERN. He has the greatest email address. It's ojeda@kernel.org. I'm very jealous. So, and yeah, he's going to show us the current state for Rust of Linux. Have a big round of applause for Miguel.
Thank you, Justin. Yeah. Okay, thank you for the introduction. Welcome, everyone. I hope you are having a great time at Rust Week so far. Also, thank you to the organizers, especially Eric and Mara, for inviting the Rust for Linux team to the event, and also to the All Hands. Also to Google for sponsoring the Rust for Linux conference room that we have, although we will most likely be in the All Hands most of the time. I hope that we will be around. The Rust for Linux team, not all of us, but quite a few of us will be around. So please, I hope we get to meet many of you. So let's get started with this. I assume that everybody here, or I think it's safe to assume that everybody here likes Rust, of course. So you know that part. Linux, you probably, a lot of you, most of you use, or of course you know what it is. So those two parts of the puzzle, you know, I will give some context a bit on Linux because maybe you may want to know a bit more on how development goes there to give some context. It has been a year since the RustNL where we were there. We were also invited. And quite a few things have happened since then. I will try to cover a bit of that because there is no time. There is too many things that happen, so it's not really possible to cover everything. But what I can tell you, and one thing to get started is, one thing has changed since last year, which is there is a good chance now, at this moment, that you are already running some Rust for Linux code in your laptop or in your system. And in particular, I looked in Google the other day for proof of that, and I saw somebody reporting in Reddit a kernel panic. That QR code is generated by Rust code in the kernel. It's, of course, a very simple use case, but that's running in I think it was Arch. The user was asking for help on Arch Linux. Yeah, so, normally I would say I would love to see more use cases of, or more people actually running the code. I think I would be a pretty bad person if I wished for you to get kernel panics just to so that you run the Rust code. But yeah, let's hope you don't get this screen. Yeah, so let me give you some context, as I said, on some context on Linux. So to put it in perspective, there are in a cycle, in a kernel cycle, a release, which takes about 9 weeks. There are thousands of merge commits, non-merge commits, happening. There is, let me put this a bit bigger because otherwise I cannot see here, and then I have to, there are thousands of developers that contribute, hundreds new every cycle, 200 companies, many maintainers there. And of course, Linux is everywhere. There are 4 billion Android devices out there. There are millions of servers. I say 100, I think Greg said 200 in his talk. Yeah, Linux is everywhere. And one note is the commits there that you see, they are not really like commits in other projects that are like small, or you have a PR with many commits. Really in the kernel, we iterate and we follow a process where every commit is supposed to be, rebase and with proper justification and long commit messages. In fact, I had a screen that I didn't add it, but yeah, it's like a PR. Sometimes you can think of a commit in the kernel sometimes as the equivalent of a PR, sometimes not, sometimes it's a patch series. But yeah, that gives you the scope of what Linux is and how many people is involved. So what is Rust for Linux? You probably know this already. I usually say this definition, which is Rust for Linux is a project adding support for Rust language to the kernel. But what that means is too generic, right? The idea is our goal has always been these things in the screen. But let me try to explain. Before Rust for Linux, there were quite a few attempts or projects that were doing out-of-tree modules, kernel modules in Rust. So they would take, for example, they would generate a static library, then they would take the object file from it, and they would link it, give the object file to the build system, and that's it. And then you would run Rust there. But that had some disadvantages. It's really out-of-tree. It's not really a way that you can support things. The standard library is not shared, and so on. So Rust for Linux was born out of the desire to have full integration of Rust into the Linux kernel. So whatever you use C for, the idea is long-term, not right now, but long-term, you can use it for anything. You can use Rust for anything that you would use C, right? It's not just for modules. It's also for things that are not modules in the kernel, built-in code. It's focused on in-tree, and in-tree versus out-of-tree in the Linux kernel means out-of-tree code is supposed to work. It's a way to start your development. But really, what matters in Linux is the things that are in-tree, in the kernel tree. Why? Well, one of the reasons is in-tree code, all the APIs inside the kernel are unstable, and therefore, it's very hard to keep up with the kernel changing APIs, the internal ones, on your module. So it's best to be in-tree. And the best supported case is in-tree and so on. Yeah. And the goal is the goal was always to upstream it, and now we are there. So that's the project. I also mentioned that Rust for Linux is, as you can see, it's like a meta project. Rust for Linux started not in the Linux kernel, of course, it was outside the Linux kernel. But it was it's a project still that involves many projects. It involves the Rust project. It involves, of course, we are part now of the Linux kernel, but also involves other projects, for example, Bindgen, let's say, Rust code in GCC when it was outside the Rust repo, GCC Rust, Cosinel, etc. We will see a bit of that. So yeah, Rust for Linux is really a big project, a project of projects, and I mentioned this also because if you want to contribute, there are many places that you can contribute. You don't need to have any kernel experience. You don't need to like the kernel. You can help us even without that. So to give you, similar to the Linux perspective thing, to give you the same for Rust for Linux, we have had quite a lot of past series, think PRs maybe, a lot of PRs. There has been a few dozen PRs to Linux Torvalds with Rust code in them. We have issues in our repo, in the repo in GitHub, as well as in other projects. We have about 7 active core team members. We hope to have more. They are all great. Some of them are here. You can chat with them. They are really, really good at Rust. And you probably know quite a few of them. So who uses Rust for Linux? There is this slide keeps growing. Of course, I give this slide, and I'm very glad that we keep growing it. So now the latest bits, maybe from last year, is the DRM QR code that you saw in the first slide. And also Nova has joined. It's being developed partly in Tree, which is a GPU driver for NVIDIA GSP GPUs. So yeah, we hope to get more of these here. But also, we have a lot of things that are not in the kernel yet, in upstream kernel, right? There is all these users and others that are outside. And you can see big names there, like Android Binder, the Asahi GPU driver, the NVMe driver that has been in the world for a while. So these projects are outside yet, but they are usable. The people that they are using it. As far as I know, the Binder driver works in, let's not say production, but real phones. Like it actually works in real phones and so on. So we may get one of these major users pretty soon. And also another thing is there is even out of Tree that we don't even know about, there is other people that come to us and sometimes say, hey, we have been using Rust for Linux for something we are doing, and it's great. And we are like, okay, fine, that's great, but they don't intend to upstream it. For example, they told us there is apparently a satellite or a spacecraft of some kind running Rust for Linux for some reason, not for the firmware, I think just for some experiment or something like that, but it's there, it's in the space running, which is very cool. Lines of Rust, to give you another way of looking at things, how we are growing. You see the releases there, the tags, and the lines of code, and you may think, oh, it's not too much, but let me tell you what happened there, because maybe you think, oh, you regress the lines of, you should put in more lines, right? Not remove them. So what happened is that was alloc. That was the standard library, alloc, great. If we remove it, that's the actual graph. Like that's the real graph of how we have been growing. And when we got into the kernel, when we got merged in 6.1, we were requested to really get it bare minimum, like really reduce it to the bare minimum that you can reduce everything. So I left, I think, only the printing, and even the printing to the kernel log I was about to remove. I was tempted to remove. So really, it's almost zero. It was really the bare minimum things that we were doing. But we had, previous to that, years of work that we were doing. So then, after that, we have been merging slowly. And why is it slow? Because in the kernel, you cannot put dev code. Okay, so and you have to justify and go through the maintainers of the relevant subsystems to get in. So therefore, we have to discuss with the maintainers. We have to review the code with the maintainers, with the experts, and so on and so forth. It has to go slowly in. And you can only upstream something when the dependencies of that is in already. So it's like a train kind of thing or a tree that you are slowly putting in. But now, you see, lately, we are ramping up. Quite a few core things have landed last year, and things are accelerating. There is a lot of code joining. And again, this does not include any of the out-of-tree code. It does not include generated code. That there are some, in C, there is a lot of lines of code there. I don't know how many. There is like a total of 30, 40 million. But there is a lot of generated code, as far as I understand, for GPU registers, things like that, descriptions. In Rust, we don't have that yet. So maybe we have once, or at some point, we have like a big jump if we do something like that. Anyhow, that's the lines of code. If I wanted to go into what we have done, it takes a lot. So let me just say, read this slide offline if you want to get more information about it. There are things like new architectures being supported in the kernel. There are features that we start using, or Rust features that we start using, compiler features, build system changes, testing things. Of course, all the instructions to actually wrap the C APIs. and so on. So there is a lot of things going, and it's what it takes to run to support Rust in the Linux kernel. To zoom in a bit, and I don't have much time on that, but to zoom in a bit, Danilo gave me these slides on what has been done for the driver core. Recently, the generic device driver infrastructure was merged. There is more buses coming and more things that are needed, especially for the Nova project, for the use case. On Nova, there is the Nova core skeleton driver has been put into the kernel, and now they are going to put the Nova DRM driver, and they are going to grow it from there. And eventually, in some time, we will get a GPU driver there. Like Asahi also is trying to, as far as I know, upstream they are pushing to upstream the driver, and the UAPI is already there. Something more related to Rust that maybe is more interesting for you is the kernel alloc. I told you that we dropped the standard library, allocrate, right? And what we did is, let's get our own alloc. Why we did that? So we were trying to, this has been going on for a few years. We were trying to see, can we use the allocator API feature? Can we use all these things to avoid having to write our own alloc? But in the end, flexibility is key in the kernel. It's great to have the ability to write your own signatures, to write your own implementation. You want to pass GPF flags. You want to do all kinds of stuff that, it doesn't fit, and it would take a long time. So we decided, hey, let's go for our own alloc, at least for the moment, and probably forever. One of the things that we want to have or try to get from the Rust project, if possible, is to be able to replicate whatever alloc, the actual alloc, the one in the standard library, does. So for example, having specialization implementations would be nice to be able to replicate some of that, or any, for example, box magic would be also nice to be able to have. Essentially, get it on par with the upstream alloc. So on another way of looking at things, growing community. We have double the number of messages that we have in Zulip. You, of course, probably know Zulip. You know it from the Rust project. We also use Zulip. Zulip sponsors us the instance as well, which is great. And it's accelerating again. It's doubling in a year. It doubles the number of messages. This I put it because it's another statistic, another graph from Zulip, and it shows the active users. Somehow, I think it's a window of 2 weeks. But what you see, the spikes there, or the heartbeats, are actually the events. So you can actually very nicely see when things happen in the news. So the first spike was the merge in the Linux kernel. The second is when a maintainer left, when Watson left. It looks like we have a bug in the slide. And the third one is the drama about the DMA thing that happened. But yeah, so I guess a lot of people join. They don't need to have an account to read because it's public now. But I don't know, the people, I guess, join or log in when there is drama. I give you this timeline. This is just to say, I am not going to go into it. There's no time, but I gave a keynote in FOSDEM where I explained the history of the project. If you want to know more, even before we were in the kernel and the team members and where they come from and quotes from kernel maintainers, etc., you can go see it. Sorry. And what I want to focus on and what I'm going to talk about now is the collaboration with Upstream Rust, because I think this is very relevant for this conference and it's quite important. So collaboration with Rust. We have been a flagship Rust project since last year. We started really the collaboration, I think, in RustNL last year, and it was great. It was really great to get that up to speed. We started a bit earlier with the meetings. We have regular meetings every 2 weeks with the Rust project. This has been key to get progress on language, library, CI, and of course compiler features and other RustDoc, Clippy, etc. So it's really great. I really appreciate that Rust got involved with us to try to get us the features that we needed for the kernel, because there are some features we cannot just use stable Rust, as it was at least back then. And that gets me to get in the CI. Back then, 1 year ago, we were in RustNL, and we got Linux building in the Rust CI. So every time you submit a PR, you are building Linux. It's not booting it, but it's just building it, and that was key. I emphasize this. It may seem trivial, but it's key for us to be able to say, hey, Linux is supported and is not going to break suddenly, even if we are using a few unstable features here and there, right? It also allows us to unpin the minimum Rust version. It allows us to unpin it in 6.11. Before, we only supported a single version. Now we support a minimum, which is 1.78. And one question that we usually get is, when are we going to upgrade it? Normally in the kernel, you upgrade the minimums of the supported tools when there is no other option, or when it would be very convenient to do so. What we are going to do for the Rust side is try to get a bigger window over time of supported releases. And one candidate, maybe, as the first minimum that we jump to, is Debian's upcoming Rust version, which includes the edition 2024. Debian we requested the Rust project and we requested them if they could do that version for Debian Trixie, and it looks like it's going to be that. That's great. We really appreciate that. So yeah, that's great. Maybe we have our minimum version there. And with that, with covering Debian stable, is enough. Yes, we don't cover like enterprise distros or anything like that, but covering Debian stable is already quite good, and I think it's good enough for most use cases. That allows us to support distributions. By support distributions, I don't mean distributions that already enable Rust, which some of them do, a few of them. I mean building the kernel in those distributions easily, so that kernel developers can do it easily. An important one is unstable features. So we are now, and I'm pleased to announce, and this is all the work of many people, we are very close to only using a stable language features, so stable Rust, okay, in the kernel. That's great. There is actually only 2 that remain right now, unless we enable more, of course. There is only 2. And one of them, because in the kernel, in the kernel tree, we don't allow kernel developers to just randomly start using an unstable feature, right? We control which unstable features they can use. And for that code that is not in the kernel crate that we call, only one is allowed, okay? And the other one is allowed in everywhere. So there is only one that is allowed everywhere and 2 counting the kernel crate. So that's great. And I hope that by next year we have this done, or actually very soon if no blockers, more blockers appear. And we are doing, of course, very good progress on compiler feature. We are focusing also there, because for the kernel there is a lot of, it's not just the language, the compiler is really a key piece it's a key piece for us, because there is, sanitizer support, target JSON stuff, new things that come in hardware and we need to support it, architecture stuff, very niche architecture flags that nobody else uses, only the kernel. And some of them, they were added in GCC and or Clang just for the kernel sometimes. So there is really some things that are needed for the kernel, and it's just, you may not have seen. But there is a lot of progress, and we want to thank everybody that is working on all those, both volunteers and people from companies. I also want to mention GCC. So GCC, both projects, you probably know them, GCC Rust and the backend Rust C code in GCC, both are important for us. We want them to succeed, both of them. We need both of them. I think it's good that both of them exist. And not just those 2, but also Bindgen, because Bindgen currently uses libclan. And it would be nice, or people at least, I'm told that people want a way to build a kernel with only a full GCC toolchain, right? So it would be nice to get some work on Bindgen to have a way to parse the code and the flags that how GCC looks at the C code, rather than using libclan and then mixing things, which is not great. Anthony gave me these slides on Rust C code in GCC. I will not go into them, but this is the last year. What happened? One of the things is that it's in the Rust CI, and they're working on the Rust app distribution support. And for the future, there's going to be LTO, which is also important for the kernel, cross-language LTO as well. The Rust app distribution should be finished soon, this year maybe. And yeah, most of these are important for the kernel, but I want to highlight 2 in this slide. One is that there is going to be a summer of code. Fractal Fear is going to be working on this backend, on the GCC one, and is the person working on the CLR one. So Anthony says that he's very excited to have somebody that talented working there, and I agree. I hope that this gives a very needed push for us C code in CCC. And the other thing is we have again experimental CI building and booting the kernel under QEMU using the GCC backend. this is another slide where Arthur gave me, this was for ForSDEM, Arthur gave me from the GCC Rust lead. So he was telling me, or he was in the quote, you can see, this will enable us to start experimenting with Rust for Linux, which we would like to be able to test during summer 2025. I don't know if that timeline will work or not, but even if it takes 1 more year, if they can manage to start looking at Rust for Linux code and compiling it with GCC Rust in even in a year, that would be amazing. Now, Coccinelle for Rust. I also got these slides from Tathagata and Julia. So Coccinelle is a tool that allows you to do something like generalized refactors of C code. And now we have Coccinelle for Rust that does the same for Rust. So if, for example, if you have a commit and you have to do some change with a lot of mechanical changes that look like mechanical changes, but it's not as easy as doing it with grep, for example, right? You can write a patch like this, which is called a semantic patch. So it looks like a patch, if you have seen the minuses, pluses in Git, right? But you can give, hey, this is expression A, expression B, and then the Coccinelle will look for that entity, that kind, and it has to be an expression, and then a dot, and then you replace that with the other, right? And it will do it whatever the names are or whatever the expressions are. So that's really, really useful. In the kernel, Coccinelle for C is used a lot. And sometimes when you go to C++, for example, you miss, or I have missed at least personally having Coccinelle for C++. So I'm very glad that we have this starting to work for Rust as well. And I hope for all of you may be useful at some point in your projects as well. Yeah, so please check it out. Very quickly, from ForSDEM, I gave another perspective of giving you what has been going on. What kernel developers think about Rust. I think it's important to mention a couple of these because I want to be clear that Rust, I think, in the kernel is going to stay. I mean, 1 year ago, 2 years ago, it would be hard to guarantee, or I think at this point it's a done deal. I don't think Rust in the kernel is going to go away. There is a lot of people involved. There's companies that want it. Even kernel developers, kernel maintainers are saying it. So in the ForSDEM keynote I gave, I ran a small survey of kernel maintainers and asked them what are their opinion on Rust. So please check it out because there are a lot of quotes, also from people from the Rust project. I didn't include those here, but I included these two. One is from Jonathan Corbett. He's it's the documentation maintainer. He's very well known. Runs or started or is the main editor of Linux Weekly News, LWN, and he says Rust for Linux is important for the long-term viability of Linux, and I am glad that it is succeeding. So when Jonathan says that and is willing to publicly say that, I think we are safe to say that we are going to succeed and yeah. Also, Greg has been publicly supporting Rust for quite a while, but lately has been emphasizing it more, even in tags that go into the Git repository. In the KubeCon keynote that he gave 1 or 2 months ago, I suggest that you check it out. He is publicly talking about Rust, which is great. What about companies? We have, I got some statements as well for ForSDEM the other time. One is Red Hat saying that they employ 3 full-time positions working on Rust for Linux. Samsung employs 1 full-time engineer. That's great. Google, of course, has a number of engineers working on Rust for Linux or related things. You can see them in the mailing list. Yeah, they want to put Rust into Android and use it. And if that happens, then in 1 year, 2 years, 3 years, when people start to get those phones or those updates, then it means we have billions of devices. Like those 4 billion devices I mentioned, we will get billions of devices running Rust. Also, Sid gave me this statement for ForSDEM. I really appreciated the kind words. I also want to say there is, for example, NVIDIA I have seen a handful of engineers from NVIDIA also participating, sending patches, reviewing patches around Rust for Linux related to the DRM work. That's great as well. So yeah, I think there is a lot of people now going on. We have sponsors for different things, industry support. Yeah, please, I want to thank all of them. And what I want to also say here is, if you are learning Rust, I see sometimes posts, for example, in Reddit, in the Rust subreddit, saying, oh, where are the Rust jobs, right? Or well, Now that the kernel, this is, as I was showing, is accelerating, right? Rust in the kernel is accelerating. There is going to be a lot of companies and a lot of posts, I hope, that they need experienced developers on Rust. So I think there are going to be jobs there. So I think for those of you that, hey, I want to work on Rust, or I want to program in Rust, yeah, maybe try to see or try to follow the kernel, because there is going to be companies demanding that kind of role. What I'm expecting, this is a personal view or a personal opinion, for the next year. So in the immediate future, I hope that we have a productive all hands. We were invited there. Again, thank you. I think it's going to be great. We are guests there. I hope in a year or so we don't use any language unstable features. I hope also that most of the compiler features are stabilized as well. That maybe we get some work on new features that we need, like field projections. That GCC, CodeGen GCC is in the CI, but not just like now, but also building Rust for Linux, like we do for the LLVM backend. Also GCC RS and binding, making substantial projects. And of course, I want more users joining the kernel, the actual code that we will all run. And of course, all the contributors and all the companies that join with that, right? So I hope that happens, or at least not hope. Actually, these ones that I have in the slides, I think will happen, right? At least personally, I expect them to happen. The field projections are RFC. I don't have time, but I want to point. Check the slides, because Benno gave me some slides on field projections. It's an RFC. It's a language feature that, of course, is not implemented, but we want to use in that kernel very dearly. And yeah, it's great. It allows you to have a new operator, the right arrow operator, and goes from a container of a smart pointer of a struct to a smart pointer of a field, and customize that through a trait and what happens there. So that's great. Please check it out. Ben is looking for feedback and review. So if you want to, for example, collaborate with Rust for Linux, yet another way is, hey, go to this RFC, give feedback, because this is going to be how we are going to write Rust code in the kernel. So you can influence that, right? You can influence a lot of code in the future that will be using this. How to contribute, I gave some tips already, or remarks. What I usually say is, go to these web pages. We have there everything, not just for the kernel, but also other projects. As I was saying, Rust for Linux is a meta project, so there is a lot of projects you can contribute to, not just the kernel, and that will benefit the kernel. So please do that. Check it out if you are interested. And I say this again and again, but you don't need kernel experience, even to work on the kernel. If you really want to get into a kernel, you don't need kernel experience to work on Rust for Linux. And in fact, you can submit patches with no kernel experience. And people have done that. And for example, Benno, I just mentioned, Benno didn't know anything about the kernel 3 years ago, something like that. Please, Benno, excuse me if I got that wrong. But he learned very quickly in 1 year, whatever. And he now is a reviewer there, or part of the core team. Same for others, like Alice or others. So really, we have a lot of people there that didn't have experience beyond others, etc. And they are contributing. So yeah, please check it out. And others, sorry, because I know Gary is there, and Gary knew about kernels a lot, so that's why I don't mention you, Gary. Cangrejos, and with this I finished. So Cangrejos is the Rust for Linux conference, or the workshop, where we meet, a few of us, 30 people, something like that, 40, before we go to other conferences, like the actual kernel conferences, right? We have had in the past presence of Rust people from Rust teams, important people from Rust, from Bindgen, etc. We would like to have more. So if you are, now that we are collaborating more, if you can go, if you have, you can spare some time to go, I think you will find it very interesting to meet kernel maintainers, talk in a small gathering. So yeah, so if you are a team member, or you are really experienced with Rust, or you can help in some way, ping us, and we can see. It's an invitation only, but yeah, if you come from the Rust side, we want to have more Rust presence there. This is how it looks. This was the first year. You may recognize people from the photos. This was the second year. We were also in Spain, and the third year we went to Copenhagen. And we had some prominent kernel developers there that you may recognize if you look closely later. So yeah, please join Cangrejos if you want. And that's it. Thanks a lot.
Thank you. Thank you very much, Miguel. Amazing talk, great insights into the project. We have room for some questions, so that's already having the catch box available.
Yeah,
Are there any questions? Over there.
Hello. Now that Rust has solidified its place with drivers, is there any thoughts about Rust moving into more parts of the kernel, maybe in the implementation of subsystems or something like that?
So actually, the drivers, I have seen people mentioning about, and it's normal, that we wanted to do drivers. I think since the beginning we said, and let me see if I have it. I think I have it in the, yeah. Okay, maybe not explicitly, but what I mean, no, there's later, no worries. What I'm trying to say is, it was not just for drivers. Since the beginning, it was not even just for drivers. And in fact, one of the first users were drivers, but also we have the DRM QR code thing for the panic, which is really, you can see it's not really like a driver handling hardware. Sorry. Oops. So, and there has been kernel maintainers that have contacted us and said, hey, I want to use it for this or for that, and they are not drivers in that sense. They are for other things. For example, we discussed and we did some, Weston did some prototyping on NetFilter stuff. There is people doing, there is many things that, for example, file system, it depends if you consider it a driver or a module. It can be a module, but it's not really a hardware driver. So there is file systems as well that you can do. And there is people considering that for sure, yeah. So I don't know when we will have the first one merged upstream, but yeah, I think it will happen sooner or later.
Cool. Let's see if there are any more questions. Oh, great catch.
You had at one slide that there is the specialization feature still not stable. Would autoref specialization work for you in those cases, or at least in the majority of cases?
I think I don't know. I will have to see. We'll have to. I guess I think we discussed it. There are some alternatives that for everything that we do, there are alternatives or alternative features. We know stabilization is not going to come anytime soon, but maybe we can do, we can do it exactly like the standard library does. So as long as we are constrained to that, and upstream Rust knows we are doing exactly what they are doing, or they support that particular use case, even if it is not stable for everybody, like the standard library, that will be fine for us. We don't need like the entire thing. As for the other alternative, I don't know. We would need to. Maybe I defer to Danilo, who has done the latest alloc spin, let's say, or alloc work. Yeah.
Right. I guess we have time for one more question. And Ted is already running. Amazing. Good catch.
All right. So my question would be: you mentioned that you can actually build with Rust 178, and you're looking for the new stable version in Debian Trixie. But you also mentioned that you're using some unstable language features still. So what's the magic to actually make that work?
So the actual technical, there is two sides of that, right? The technical magic is the Rust bootstrap thing that we use. But the thing is, we only use a few of them, and we control which stable features are used. And upstream Rust knows which unstable features we are using. And that's why we wanted to have that CI, building the kernel in the Rust CI, because yes, we are using unstable features, but really we are using them in a way that you could say is like an extended special standard library as well, or something like that. The kernel is like a special case where, yes, we use unstable features, but that's fine. Now, on the other side of it is we do conditional compilation sometimes, or we do in the build system as well things to support several compiler versions. For example, we are using arbitrary self-types, and before we were using other features, or derive coerce pointee, and now before we were using other features that were used to implement that. So we do conditional compilation to support. So in all the compilers, we use something. In new compilers, we use something else. So that's why when we update the compiler, the minimum version, we can remove all that. All those workarounds, so to speak, and then we use the stable version of the features. So yeah, there is some magic, but that's why we wanted to start the collaboration, and that's why we are very thankful to the Rust project to have these regular meetings where we say, hey, we are going to do this, or we are going to do that, it's okay, what should we do here and there? So yeah, I hope that explains a bit. But yeah, we are cheating slightly, hopefully just for some time, for some months or a year or most hopefully 2, and we are not cheating anymore. Even then, apart from the language features, there is a lot of other features that may come, like compiler flags. Compiler flags can always arrive, and they are actually unstable, and we need them. So yeah,
All right, so I have one question. What does cangrejos stand for?
That's a good question. Yeah, cangrejos is the Spanish word for with a C would be cangrejos is the crab. So a crab, it's a reference to ferries. So with a K for kernel, so cangrejos.
Oh, no, this is beautiful. I love that. That's great. All right, thank you, Miguel. Thank you very much.
Thank you.
If you have more questions to Miguel, he will be here all day and for the rest of the week, I guess.
Yeah,
because
we
it's
will be
Rust
also
week.
in the
And we now do a stage switch. We set up Matt Campbell for the next talk. We see each other in round about 10 minutes at 10:25. All right. Oh, lights are going down. All right. Welcome back, everybody. Welcome to the second talk of today. On the main track, we're now talking about UI accessibility, reusable UI accessibility written in Rust. And for that, we want to welcome Matt Campbell. Matt worked for the past 2 decades, I guess, on 2 Windows screen readers, one with Microsoft. He developed the third-party one and is now implementing cross-platform accessibility in Rust and beyond. The most important information, though, is that Matt is an avid karaoke singer, and he has memorized over 80 songs for karaoke. What's your favorite song, Matt?
Everybody Wants to Rule the World by Tears for Fears.
Amazing. Hey, let me tell you, you are at home in the Rust community. The Rust community are avid karaoke singers as well. So if anybody of you has been at one of the Rust fests in the past, karaoke was a staple there. But yeah, before we are going to sing karaoke, let's hear about your accessibility. Have a big round of applause for Matt.
Thank you. It's great to be here. So I'm here to talk about an open source project called AccessKit, which is written in Rust and designed to be used in other languages as well. So what is AccessKit? It's a library that GUI Toolkit developers can use to implement accessibility. And by accessibility, I specifically mean here exposing the content and structure of your UI in such a way that it can be used by people who use certain assistive technologies, including screen readers for blind people, screen magnifiers for people with low vision, and certain alternative input methods such as switch-based navigation and voice commands. AccessKit aims to eliminate for the toolkit developer a lot of the incidental complexity of implementing accessibility from scratch. And it does so by providing a cross-platform abstraction over the various platform-specific accessibility APIs. These APIs tend to rely on fairly esoteric platform-specific technologies or specific programming languages. For instance, the Windows UI Automation API is based on Microsoft's Component Object Model, or COM. macOS Accessibility is based on Objective-C. The accessibility protocol for GNOME, KDE, and other free desktops on Linux and other free Unixes is based on Dbus. And Android accessibility requires you to write in Java. So AccessKit encapsulates all of that into a single cross-platform abstraction. And in fact, AccessKit is already usable across all of those platforms that I mentioned. And as I said, it's written in Rust, but designed to be used in other languages as well. And I'll be discussing and demonstrating that. So with that, I'm going to play a couple of pre-recorded demos, which I will narrate as they play. For this first demo, I'll be showing an application using the Xylem Rust GUI Toolkit. And specifically, I'll be showing the Xylem To-Do MVC example application on Android using the TalkBack screen reader.
My next task, edit box. Double tap to edit text.
So the TalkBack initially puts the accessibility focus on the first widget on the screen, and there's a highlight rectangle around the widget with the accessibility focus. Now I'll swipe right to the next widget.
Add task button. Double tap to activate.
So now the focus is on the button, and we'll double tap to activate it. And it did add the task to the to-do list and clear the edit box, although AccessKit on Android doesn't currently have a way to announce such changes. Now we'll swipe back to the edit.
Edit box. Double tap to edit text.
And as you can hear, it's now cleared. We'll swipe forward to the first checkbox in the to-do list.
Add task button. Double tap to activate. Not checked by milk checkbox. Double tap to toggle.
And we'll double tap to check it.
Checked.
It did announce that because it's a change in the accessibility focused widget. We'll swipe back to the edit.
Add task button. Double tap to activate. Edit box. Double tap to edit text.
And we'll double tap to start editing. And for speed, I'm entering some text using a physical keyboard. That's why it's not showing the soft keyboard.
T-E-S-T. Test. T-A-S-K.
And those echoed characters and the echoed word are based on text change events that AccessKit is firing. So the application is updating the accessibility tree as you enter text, and then AccessKit is firing those events. Now we'll start swiping up to move backward through the text. Wait for the demo to catch up with me. I left too much space there.
K S A T
And now we'll start swiping down to move in the other direction.
T A S K, end of field.
And the text cursor is also moving as we move through the field with TalkBack. So that's a demo of a simple Android application made accessible with AccessKit. And wait for the demo to finish playing. So to clarify a few things before we proceed, AccessKit does not automatically handle everything that's needed to make applications accessible for various different disabilities. For instance, it's the toolkit or application developer's responsibility to take care of different color schemes or different display styles generally. So providing high contrast if that's what the user has indicated they need through system settings, and light versus dark mode. And of course, that one is pretty common, pretty well expected of modern applications anyway. Also, and this is especially important on desktop platforms, keyboard commands are the toolkit's responsibility. Now, it's true that screen readers provide some keyboard commands of their own, but accessibility is about more than just screen readers, and even there, the toolkit is responsible for certain things like navigating with Tab and Shift-Tab, or in some cases, moving through a list control with the arrows. Also, AccessKit is completely disconnected from the rendering part of your toolkit, so AccessKit in itself doesn't have any effect on the way that your UI looks. Now, there are some things that do have an effect on the appearance, like the highlight rectangle in the previous demo, but those things are typically handled by the platform or an assistive technology as either an overlay or a post-processing step with help from the compositor. And you can use AccessKit with any rendering technology. So whether you're using WGPU or OpenGL or Vulkan or whatever, you can make your toolkit accessible with AccessKit. So I mentioned exposing the content and structure of your UI, and here I want to show a partial and simplified example of what that means. So this is called an accessibility tree, and it's a hierarchy of UI nodes. And if you're at all familiar with the document object model, or DOM, from the web platform, then this is conceptually similar. Each node has an ID, a role, one or more properties, and optionally child nodes. One property that I'm not showing here is the bounding rectangle, but that is what allowed that highlight cursor to work. So at the root, we've got our window node, and then the window has a child node for each of the widgets. The text input node has a text selection, and I've omitted the details of how that's represented, but it's there. And then the text input has one or more text run child nodes. A multi-line text input would have at least one text run per line. And when you get into things like rich text and bidirectional text, then you often have multiple text runs per line. And then finally, the button node has a label node as its child, because that is how the widget tree is represented in Xylem. The label is a child widget of the button. So that should give you a little more concrete idea of what exactly a toolkit needs to expose through AccessKit. So now we're ready for our second demo. This one is not directly written in Rust. This is a simple game using the Godot game engine, which recently integrated AccessKit across the 3 major desktop platforms. So we have a game engine with accessibility built in. And for this demo, the co-developer of AccessKit, Arnold Lubria, took an existing tic-tac-toe game that was written using the Godot engine, and he made it accessible with AccessKit. So for this demo, I'm using the NVDA screen reader on Windows.
Tic-tac-toe window, blank, center.
So we're in the center of the tic-tac-toe board. When the window comes to the foreground, AccessKit fires a focus event, which indicates which node in that window currently has the focus, and that is what triggered that screen reader announcement. Now we'll press the down arrow to move to another place on the board.
Blank, bottom.
So that down arrow keystroke was handled by the application, which moved the keyboard focus. It updated the accessibility tree, and in response, AccessKit fired a focus event, which triggered the screen reader announcement. Now we'll press enter to fill that spot on the board. Wait for the demo. Come on. I left too much space.
Cross, bottom. Your opponent plays bottom left.
And that specific announcement was provided directly by the application using what we call a live region. It's similar to the concept with the same name in the web platform. So now we're going to up arrow to move back to the center.
Blank, center.
And we'll press enter to fill that spot on the board and
Cross,
see if we can.
center. Your opponent plays top.
It's not going to let me do a vertical row, so we'll do right arrow to try the center right.
Blank, right.
And we'll press enter to fill that spot on the board.
Cross, right. Your opponent plays bottom right.
Okay, it's not going to stop me from doing that horizontal row, so I'll move left back onto the center.
Cross, center.
Which is the one we already filled, so we'll left arrow again.
Blank, left.
And we'll press enter to fill that spot.
Cross, left. You win.
And again, using a live region, the application announced that we won. So that is a simple demo of a game made accessible using the Godot engine and AccessKit. So now I want to talk about what I think is the most distinctive feature of AccessKit, which is what I call the push-based architecture. So I'll describe this by way of comparison to the way that the platform accessibility APIs work. The platform APIs are pull-based, which means that they rely heavily on callbacks to traverse the accessibility tree and query information about properties. And those callbacks, as I mentioned, are usually implemented using some kind of object-oriented interface. With AccessKit, on the other hand, the toolkit developer populates a tree update data structure with one or more of those AccessKit tree nodes, and it initially provides a full accessibility tree up front, in which case it also includes a different structure with top-level information about the tree, and then after that, it provides incremental updates, and for each tree update, the toolkit calls a function in AccessKit which effectively pushes that update to AccessKit, which then maintains a tree in memory and implements the pull-based platform APIs. This model is based conceptually very strongly on what Chromium is doing internally with the way that it pushes tree updates from the sandboxed renderer process to the unsandboxed main browser process, which is what actually implements the platform accessibility APIs. Now, in the case of Chromium, it's actually using IPC and serialization. In AccessKit, it's just passing data structures into a function, but it's conceptually very similar. And what this means for UI toolkit developers is that sending an accessibility tree update is conceptually similar to drawing a new frame of the UI. And in fact, you can put that in the same place in your UI lifecycle. So at the same time that you're drawing a new frame, you can push the corresponding accessibility update, and it's way less reliant on callbacks than the platform APIs are. And in fact, the main callback that you need to implement is what we call the action handler callback, which handles things like when I was double tapping those buttons in the Android demo, that was handled through a callback where AccessKit calls into the toolkit, and that is conceptually just like your regular event handler. So it should feel pretty familiar to a toolkit developer, much more so than the platform accessibility APIs. This also means that this model works quite well for immediate mode toolkits, such as the popular eGUI toolkit, which in fact was the first toolkit to get a full-featured accessibility implementation using AccessKit. And in particular, since immediate mode toolkits tend not to maintain a lot of state between frames, the toolkit can just push a tree update at the same time that it's drawing a frame. And in fact, the toolkit can push a full tree update every time, and AccessKit will do a diff between that and the existing tree to figure out what changed and which platform events need to be fired. So now I'm going to dive a little deeper into the latest platform adapter or backend that we use to that we added to AccessKit, and I'm going to discuss how we took a layered approach to balance two of our goals for the project. And we have a similar layering going on with the Windows and Mac OS adapters. So at the lower layer, we have the adapter struct, which has functions corresponding to the Java methods that an Android view would need to implement to be accessible. And this is designed for cases where you are writing your own Android view subclass and you want to directly and with as little overhead as possible integrate accessibility. And one example of an Android view implementation that uses this is I've been working on a new crate called Android View, and a full discussion of Android View is beyond the scope of this talk, but I've provided a link here to the current repo, and it's basically designed to be a low overhead, maximally flexible way of implementing an Android view in Rust, whether it's for a full application or just an embedded piece of UI. And there are two demos currently in that Android View repo, and they both use the AccessKit Android adapter at this level. Now, at the higher level, we have another struct called injecting adapter, which is designed for cases where you're not implementing the Android View class yourself, and you need to just retrofit accessibility onto something that already exists. And in that case, we handle the Java and JNI glue code for you. And the downside to that is that there's some overhead of forcing things to be sent to the UI thread, so it works regardless of which thread you're doing the tree updates on. So it's not as low overhead as the lower level adapter, but it's designed to be easy to integrate. And an example of where we would use that is if you're using either the native activity or game activity class, which are the two options currently supported by the Winit cross-platform windowing library if you want to run a Winit-based app on Android. I've got an insect buzzing around here. Go away. Yeah. And so, yeah. So if you're using Winit, then you can make that accessible with this higher level injecting adapter, and that would also be what you would use with a cross-platform library such as SDL once we add Android to our language bindings. So this layered approach allows us to balance two of our goals for AccessKit. On the one hand, we want AccessKit to be as efficient and low overhead as possible. Ideally, as close as we can get to zero overhead, because that's the Rust way, right? And because we know that a lot of UI toolkit developers care a great deal about performance and efficiency, and we want these developers to make their toolkits and applications accessible. But at the same time, we also want to make AccessKit easy to integrate, because we believe, again, that will allow more toolkits and applications to be accessible. And speaking of making more toolkits accessible, even beyond Rust, let's talk about language bindings. So far, we have C So we implemented a wrapper library with a C-compatible ABI, and then used cbindgen to generate the header file. And we have a cross-platform example of using that with SDL. We have Python bindings written using Pyo3 with a cross-platform example using Pygame. I did some work on Java bindings using the crate called JNI, and manually writing the corresponding Java glue code. And that was about 2 years ago, so I need to update that. We did a proof of concept Unity plugin a few years ago, and we'll probably rewrite the C# bindings part of that at some point. And then we would also like to do bindings for Go and C++. Of course, you can already use AccessKit from those languages and more using the C API, but we would eventually like to provide idiomatic language bindings as well. And we welcome work on more language bindings, but there's a problem with the way that we're currently approaching language bindings, which is that we're manually developing and maintaining separate bindings for each language. And in addition to just being tedious, it's also error-prone, particularly when you have to implement an ABI in Rust, typically requiring some amount of unsafe Rust code. And pretty much the only language so far where we don't have to do that is Python, because Pyo3 is excellent. Another problem, though, is, and even with the Python bindings, is that the language bindings don't automatically pick up all of the documentation from our native Rust API. So we need to manually copy and adapt doc comments when we remember to do that. There's a couple of different ways that we've been thinking about and talking about dealing with this. One would be to write our own code generator that can generate part of both the base AccessKit crate and the language bindings from some kind of IDL or interface definition language. The other thing, though, that might be even better is to leverage an existing Rust-based tool for generating multiple language bindings. And the leading candidate for that approach is the Diplomat project. We haven't yet made a decision on that. So let's talk about what it's going to take to get AccessKit to version 1.0. So we do want to get to a 1.0 that will allow us to have the same stability guarantees as Rust itself, which means that ideally, once we get to 1.0, we would never have to do a semver breaking release again. But there will probably be more breaking changes before we get there. I realize that some people are frustrated with the level of churn in the Rust graphics and UI ecosystem, but when we get to 1.0, we want to have an API that's as approachable and easy to use and logical and as free of legacy cruft as possible. So bear with us. Stabilization is coming sometime. Until then, we need to do some more work on text support, particularly rich text and some level of hypertext. By rich text, I mean exposing things like font, family, size, and styles, indentation, heading levels, and maybe some other document structure. For hypertext, we at least want hyperlinks. Full HTML support is a very deep rabbit hole, so we probably won't do all of that before 1.0, but we at least want to make sure that we have the right foundations in place. Next is scrolling in virtualized lists. And virtualized lists are large lists where not all of the items are necessarily materialized at the UI level or even have their data in memory at one time. And we want to make sure that these are implemented efficiently and that at the same time they expose the information that assistive technologies expect. Fortunately, the Xylem GUI toolkit that I demoed earlier now has support for virtualized lists, so that's something I'll be working on soon. We have some more widgets to implement, including menus, tables, and tree views. These tend to be desktop-specific widgets. There may be a few more mobile specific widgets that we need to work on, particularly when we get to the remaining platform adapters, particularly iOS and Canvas-based web applications. Now, to be clear about what I mean by Canvas-based web applications, these are web apps where the whole UI is rendered as one Canvas element, typically using something like WebGL or WebGPU. And these web applications are not going to be perfectly accessible, but we're going to do the best we can within the constraints of current web standards. And finally, we realize that we need more documentation, particularly conceptual and tutorial documentation for toolkit developers who aren't already specialists in accessibility. So, how can the community help? First of all, we want more toolkits to integrate AccessKit. This is what matters more than anything else. We want as many toolkits and applications as possible to be accessible. On documentation, if you feel qualified to help us write it, then that's great. Otherwise, at least ask us questions so we have a better idea of what needs to be documented. And on language bindings, if you want to talk to us about either the custom code generator approach or using something like Diplomat, that would be great. Otherwise, if you want to go ahead and write your own bindings for some language in the current manual style, then go ahead and you can at least do that as an unofficial package, and especially if writing language bindings is going to unblock accessibility efforts for some toolkit or application. So a few special thanks before I finish. Arnold Lubria, my co-developer on AccessKit, who is here at the conference today, and he has done most of the work so far on the Unix/free desktop backend and the C and Python bindings. And he's also been doing code review for my code since very near the beginning of the project. So thank you, Arnold. I'd like to thank Google for providing funding for AccessKit development for multiple years now. AccessKit would not have gotten nearly as far as it has without that funding. And finally, thanks to everyone who has made Rust the great systems programming language that it is, especially for developing projects that can be used in other languages as well. And with that, I'll provide a link to the AccessKit website, my contact info, and my GitHub sponsor page if you're so inclined. Thank you. I'll be happy to take questions.
Thank you very much, Matt. An amazing talk. I loved it. Let's see if we have some questions. Tats is already throwing the catch box, and yeah, caught it. Amazing.
Great talk. Thank you so much. I had a question about terminal user interfaces where you're not in control of the application, the terminal emulator. Would it be possible to use AccessKit in applications like that?
I've actually thought about this, and I think what might be, well, at least for cases where the terminal emulator developer would be willing to cooperate. Of course, we've got at least a couple of terminal emulators written in Rust. It might be feasible to add some new terminal escape commands for sending serialized accessibility tree updates through the PTY and or the SSH connection, as the case may be, and having the terminal emulator expose that to the screen reader or other AT. I mean, I've got a few other projects that I would like to work on someday. This is one of them, but I have given it a little thought.
Cool. Thank you.
Thank you. More questions? Okay, I'm not seeing the box anymore. Oh, there it is. Cool.
Thanks for the talk. What I was wondering while I was listening to your talk was how can people who are new to accessibility test whether their programs can be used by people who need extra help to work with your program?
Right. So all of the major operating systems have a free built-in screen reader now, and I can just go down the list. With Windows, you can turn on Narrator with Windows Control-Enter. On Mac OS, you can turn on VoiceOver with Command F5. On GNOME, you can turn on Orca with Alt-Super-S. On iOS, you can turn on VoiceOver by, it's in settings somewhere. Same with TalkBack on Android. And I realize that to some extent I'm asking you to like jump in the deep end and learn a whole different way of using your device by doing that, but that is really the way to get the actual experience. There are other tools that you can use to just make sure that your accessibility tree is correct. There's Accessibility Inspector on Mac OS, Accessizer, that's ACCER on GNOME, and Accessibility Insights on Windows.
And are there also tools for integrating it in a CSCD?
One thing I can point to, if your GUI toolkit of choice supports it, is there is actually a Rust crate called Kit Test, which allows you to do headless GUI testing using AccessKit. So it doesn't like set up the full end-to-end setup with the actual platform accessibility API and the and an actual assistive technology, but it does allow you to test in a convenient way that your accessibility tree is what you expect it to be.
All right. Any more questions? I see a hand over there.
Wait, I can hear myself. Really great talk. The question I had, sorry, the delay is messing up my voice. So it seems like this is designed for exposing like the accessibility information to the platform itself. And I'm curious what like downstream assistive technologies, like how you'd be able to implement that across platforms, maybe like desktop in particular. So like if you wanted to actually be able to read the accessibility information and design your own technology.
So like if you wanted to implement your own screen reader or the like?
Yeah.
I don't have anything to help you with that. You would still be on your own working with the platform-specific APIs. There are Rust libraries that you can use to help you with that. For instance, the Windows crate on Rust, obj-c2 on Mac OS, ZBus for Linux. But you're still pretty much on your own working with the platform APIs directly.
Right, I guess we have time for one more question. I guess you see the hands better than I do. Oh, there's the box.
Thank you very much for the talk and for working on AccessKit. You have in front of you a significant part, a lot of people from the community and from the project. Are there things that the toolchain, the community could be doing for making the life easier on not only the end users, but rather the developers that want to use Rust, that need accessibility?
Nothing immediately comes to mind for me. I mean, you're already providing like a command line tool with Rust Up, and like command line is about as accessible as it gets, and people can already use whatever IDE they want. A lot of blind programmers that I know use Visual Studio Code, so that's already in pretty good shape.
All right, thank you very much. Matt, thank you for your talk. It was an amazing talk. It was an important talk, I think. I didn't realize for half the time that those demos were pre-recorded. I actually thought
I said they were.
Oh yeah. But amazing. I think you will be around for the rest of the conference, so if somebody wants to catch up with you.
My plan is to head to the GoSim. So we have a table in the GoSim Spotlight area. So I think I'm probably going to be heading there like shortly after this.
Amazing. All right, so please give a final round of applause for Matt.
Thank you. We are now entering
our first break for 40 minutes. There will be catering downstairs. And the sessions resume at 11:40. See you then.
Are we on? Yeah. Welcome back. Thought I would start with a joke. Why do Rust programmers wear glasses? Because they can't see. We would like to thank our sponsors. We have two sponsor announcements right now. We have Espressive and Phlox. They both have booths down there, so you might want to check them out. You get free microcontrollers. But you only get the Rust jokes in this room. Our next guest is Joe Beer Pixton. And he works on something really interesting, which probably a lot of you use or depend on, maybe knowingly or unknowingly, because he works on Rustls, or Rust TLS, as I would pronounce it. It is a TLS library in Rust, completely written in Rust. And he spoke at RustNL last year, and he talked about a drop-in replacement for OpenSSL. Now, one thing that I like in particular about your biography is that you say you do like gardening. What is it about gardening that you like?
It doesn't involve any computers.
And with that, take it away.
Thanks. So I can skip over that. I have one point of order before I start my talk, which is some unfinished business from my talk last year. At the end of that, someone asked a really great question, which was, did I find any memory safety problems in OpenSSL while I was doing that work? And the answer was yes, but it wasn't publicly disclosed at that time, so I couldn't really talk about it. But now I can. And so this was a bug which lasted 13 years. It affected basically every OpenSSL version, plus boring SSL. Google paid me a little bounty for that. That was very nice. This line of code here, if you give it to node 9 or before, that will give you a TLS client which leaks up to 255 bytes of its heap to the server when it does the connection, which is really good and normal. But it's not such a disaster. It hasn't, in like half of it, the latter half of its lifetime, it hasn't really been exploitable so much. But quite interestingly, once you kind of know that this bug exists and can cause like crashes and what the crashes look like, you can go and search GitHub and find people. I found one person who was developing the OKHTTP library on Android in 2014, and they're just there in GitHub issues, pasting bits of their heap into an issue saying, why is this happening to me? Why is this happening? So it's in retrospect, and that was before Heartbleed as well. So this was happening in the wild before Heartbleed, which is quite entertaining. I'd also say that like this bug has outlived the enormous amount of money spent on auditing OpenSSL since Heartbleed, which again is like an interesting thing to think about. You know, you can kind of imagine there's some very long tail of vulnerabilities, and I think this is probably at the very long tail in terms of length and how long it has survived in the wild. So, getting onto this talk, I'm going to answer the question very, very quickly, does Rust need more cryptography options? And if the answer is no, then this is a very short talk. And then I'm going to talk about optimizing compilers and their kind of fraught relationship with cryptography code. And then I'm going to talk about this project a bit more. So, does Rust need more cryptography options? I think the answer is yes, but I'm going to try and like motivate that more. And this is just my opinion. It's just an opinion of one person, so take it with as much salt as you like. So I'm going to go through in a few sort of categories like portability, so architectural and operating system portability, build simplicity. So how annoying is it to build as a crate? Performance, and I'm thinking about runtime performance only, not build time performance. And then assurance, which is it's a mix of two things. So a normal cryptography library, I would say, is like 3/4 maths, and it's just like straightforward. I mean, it's complex, but straightforward. And this component of it doesn't tend to have memory safety issues. But then the remainder is parsing some of the worst formats known to man that we've possibly come up with as an industry. So ideally, we'd like that part at least to be memory safed. I don't think I need to argue that any further. So AWS LCRS, this is doing really well at performance and assurance. They've done a huge amount of work on like formal verification of their cryptography. I'm taking off 1 star for like the amount of memory safety going on in some of the parsing code. But yeah, the other thing to say is like, it's quite portable, but for more esoteric platforms, it can be very annoying to build. Very kind of manual, lots of separate dependencies and stuff. And then Ring. So Ring, like the OG Rust crypto library, and kind of made it possible in the first place to write Russells. So I think everyone owes a great deal of gratitude for that project and the amount of work that's gone into it. It's got pretty good performance. It's got pretty good assurance in the sense that memory safety and parsing, and also there's quite a bit of sort of formally verified maths in there as well, which is really good. And now I'm Rust Crypto and Dalek. I'm kind of squishing them into one because that's how they feel to me. They share quite a lot of maintainers, but they've got really good portability and build simplicity because fundamentally they are a vast majority of just pure Rust with some extra options for like using some assembler and stuff. The performance, I would say, varies from world-beating, incredible, to not so good. And the assurance, again, is like varies from really good to not so good. But I think most of these 2 stars is coming from the amount of like memory safe code that is involved here. And then there's this project, and you're probably going, "Oh God, he's given himself 5 points. What an idiot!" But this is coming at the cost of portability, and I'll talk about that later in the talk. So the next thing I'm going to talk about is optimizing compilers, and this is a kind of complex issue, and I'm going to try and make it as simplified as possible. But I don't think I do a super good job. I'm not talking about Rust-C specifically here. I'm talking about basically every optimizing compiler. So GCC and anything using LLVM, and yeah, they all have, to one extent or another, in the past and probably in the future, have these sorts of problems. And the reason is you can't tell the optimizer what are sort of side channel goals are for cryptography, and you're probably going like, what's side channel and what are your goals? So I tried to think of like a really accessible analogy for this and failed, so you're going to have to put up with this. Say you're a spy and you want to have a meeting with other spies, but it's very, very important that no one knows how many spies are in this meeting. And say, just suspend belief for the moment, that you can arrange for everyone to go into a meeting room and not be observed going into the meeting room or coming out. Now, at this point, you've leaked quite a lot of information to someone who can observe the meeting room afterwards. For example, someone can measure like the CO2 in the room afterwards. that would be a good side channel because CO2 sort of declines, I guess linearly with the number of people breathing in the room and the amount of time they were in there. You could like measure the temperature of the seats. So that's another sort of proxy for how many people in the room, assuming people aren't sitting on their laps or moving around all the time. And you can also look at like the size of the meeting room, the capacity of it, because that gives you an upper bound on this like secret value. And so these are all like, there's probably other ways, these are all like side channels, if you like, on the number of people who are in the meeting. And that's quite close to how cryptography works, because we have secret values, and then we have kind of quite lossy and noisy ways that those secret values leak to people who are observing the computation. So let's say we've got a function, it does some cryptography, and it's a pure function, it's got inputs and outputs, and then we categorize the inputs and outputs into like secret values that we want to keep secret, and everything else. And so, for example, say you're signing an email. The email that you're signing is public, and the signature that you produce is public because you're just about to put them in an email and send them over the public internet, but the private key is secret and you'd like to keep that secret. And then when someone receives it, they do this operation, and you'll notice that there's no secrets involved at all in this. If you know like the root of the word cryptography, you may be like, is this cryptography? Well, it is, because modern cryptography is like largely outgrown like the Roman origin of cryptography, maybe earlier than Roman. Anyway, so the important thing to say here is that this is like completely public. It's a public operation, but we do want like it to be correct. That's the most important thing. And when you're optimizing this sort of code, you don't have to worry about side channels. There are no secrets. So that's a different problem to almost everything else. So now I'm going to add another a sort of third component. I'm calling this a trace because that's what's used in literature a lot. But you can think of this as like a log file of everything the CPU did while computing this function. And so it contains all the instructions, all the memory accesses, but it doesn't contain the data that it was operated on or like the memory contents of the memory accesses, because if it did, then we wouldn't be able to keep a secret for this. So we're not doing this literally. It's like a thought experiment. We're going to give this trace to our adversary and make them as powerful as they can possibly be with like our understanding of how you can observe a CPU executing instructions. So our first goal is basically that there's no data dependency between the contents of the trace and all the secrets, inputs and outputs. And if that's not true, so we basically achieve that by not having any branches on secret data and not doing any memory accesses depending on secret data. But nevertheless, we actually still do need to do these sorts of computations. So like, how does that work? So I'm talking about this table selection idea. So say we've got this table of data, 16 items, doesn't really matter how tall or wide this is. And we want to extract the fifth one, but the fact that it's the fifth one is secret. So we can't just access the fifth index or fourth index here of the array, because that would immediately leak the address, which contains like some multiple of 5 to our trace, and we don't want to do that. So instead what we do is just we access every single one of them in any sequence we like, probably just linear, and then we compute a mask for the one we actually want, and then do this. So here we're basically doing the same operation irrespective of the value of the one that we want, and that fulfills our goals basically for the first goal. But we've got a second goal, and this is just really annoying. There are some CPU instructions which are just not, we don't want to use them for cryptography, especially division. Nonetheless, a couple of years ago we had new cryptography, post-quantum cryptography, like brand new stuff, a reference implementation which used division. This goal is, I think, shared generally by cryptography people, but is still not amazingly adhered to, shall I say. The other thing on ARM, we've got this really interesting DIT bit where you basically tell the CPU, I'm executing cryptography, please do your very best to make sure that you do not screw me when it comes to this goal and the previous one. So that's a summary of where what the goals are when talking about side channels. And we did have a sort of proposed improvement for this for RustC. It came out of a workshop in New York in 2020. And that's very interesting and, like, I would say, not reflected in any other high-level languages. Just like the very idea of even doing this. I mean, it didn't happen, but the reason it didn't happen is because I think no other languages are really interested in doing this, and it will require quite a lot of work on the behalf of LLVM. And I guess at the time, and probably maybe now as well, that work in LLVM would be kind of very specific to a feature that only Rust was interested in. So what we did get on that RFC was some really good, like a huge, well, if you've ever read an RFC, I'm repeating myself because like everything's huge, but Peter Schwaber here is a really well-respected, like internationally respected cryptographer. And if you have a phone or a laptop that you've updated in the past year to 6 months, you are running algorithms that he has worked on. And he effectively says, like, if you're doing anything more high level than assembly, you are going to be bitten at some point by your compiler. And how's that going? Well, it's not going super well. So the sort of conclusion there is assembly is probably the right language for high assurance cryptography. And that moves us on to the next point. So there's this really good and interesting project called S2M Bignum that came out of AWS, and it's formally verified cryptography, quite low-level routines in ARM64 and 64-bit Intel assembly. And the formally verified bit is quite important because this is a very low-level language, and so we want to be sure that it's like correct. But also, this is firmly in like the 75% of your cryptography library, which is doing hard maths that needs to be fast. And there's an entire like class of correctness bugs, which I'm not going to say endemic. They were endemic. They have been a problem over a long period of time. And the best idea that we have for addressing those is formal verification. So to give you an example what formal verification means, say you've got a function which adds two numbers. Formal verification basically proves that that function adds two numbers. It doesn't add two numbers and then 1 in 2 to the 64 times gets it wrong and adds an extra bit. And this is basically what this bug in Golang was. And it was massively, well, it was really interesting in the sense it was exploitable. And you could like leak key material through this 1-bit error with very, very low probability. So normal software testing won't find you this bug, usually. The tool we have is formal verification for that. Now, using assembly from Rust, you may think, oh, this is going to be a trivial part, but actually I'm making a right meal of this. So the traditional thing is just to give it to a CPU processor and an assembler, and then link it into the final crate. I'm not going to cover this a lot because it's not what I'm doing, and it's also like doesn't address my goals for making this crate easy to build. So specifically like Windows users, have a real problem with like installing an assembler. And that's fine, not a problem for Windows users. Maybe it's a problem for Windows. So instead, what we're doing is like at development time, converting the assembler to Rust containing inline assembly. And you may think, oh, well, that sounds quite easy as well. And it actually kind of is. It is working pretty well. And we get some nice things, like we don't have to worry about symbol mangling and function entry and exit ABIs and all this stuff. It's the compiler takes quite a lot of this very uninteresting work away for us, and that's great. And the converter is built in Python. Please don't hate me. So what does it look like? So this, like I said, the assembler is kind of a mix of some assembly macros, but mostly C preprocessor macros to do like give things names and repeat bits of code. And that's what this looks like. So this is not an amazing advert for Rust macros, but I think it gets better. We've got lots and lots of macros in the crate as a result, but they're all like auto-generated through this process. We've also got like in the input code, there are some C preprocessor function-like macros, and these expand quite nicely. I think this is actually pretty reasonably readable. Maybe that's a problem with my brain. The other thing is we can, like I said, we can throw away all the ABI handling that the original code contains because the Rust compiler is doing that for us. So this is just a general overview of what like the input and output looks like. I'm doing my very best here to make the output recognizably the same as the input, just for readability, because there's a lot of comments in the input, and I'd really like to keep those and respect the amount of work that's gone into those. This whole process isn't automated completely, so you still have to write some Rust, like the function introduction here, and how to take the Rust types and convert them into the values that the assembly expects. But actually, I think this is really not very awful, and it's quite limited. So now we're getting on to like the actual point of this talk, which is to introduce this library. So the goals really are for it to be like really easy and fast to build. And I obviously want to use make it easy to use with Russells. And so that means targeting cryptography used in TLS. Competitive performance, I think, is very important too, because it's quite easy to make a slow cryptography library. And also licenses. I didn't talk about licenses, but actually this whole project came from last year. I had some conversations with people, and one of the common points was around the sort of vestigial OpenSSL license in some of these projects. Now, I would say that Ring earlier this year has fixed that, so that's really great. But nevertheless, like it being under a permissive license is quite important to me. So where are we at with that? So very like minimal build requirements. Around 1 second build time, that's just on 2 laptops I use for development. This is not like a commitment, and it will probably change over time. 2 dependencies only, which you probably have in your dependency tree anyway. And 99.7% line coverage, so there's some work to do there. And that's not a joke, because like I said, all the maths is very like top to bottom. You execute all the code or none of it. This is the features that are implemented. This is basically what gets you off the ground to do TLS with the vast majority of servers on or clients on the internet. And to split these in two, so the public key parts at the top are all backed by S2M Bignum, and the ones at the bottom are all like new Rust code using intrinsics for performance. And then portability. So as a result of the S2M Bignum thing, basically just targeting the two most common architectures, probably for the foreseeable future, although I'm thinking about like how to move away from that should it become necessary. And again, like widely used cryptography only, I'm not going to start like broadening significantly the scope of this crate. That's kind of how to use it. It's quite kind of boring, but just to say that there's a Graviola crate, there's a Russell's Graviola crate which uses Graviola and expresses it in terms of a Russell's crypto provider, which is the abstraction we have for replacing all the cryptography in Russell's. So performance, this is like, there's a suite of benchmarks, and this is a result from those ordered left to right, fastest to slowest. Also, you'll notice in here Golang is there. I have a great deal of love and admiration for the Golang standard library, so I've included that here because that's like a really good, and I think one of my goals is to be as good as that. But you can see that the performance is pretty good. So this is signing for TLS servers, signature verification important for TLS clients, key exchange, which is important for absolutely everything, and then bulk encryption. So this is not so good. I would really like to be able to use ABX512 intrinsics in stable Rust, but I know that is coming. I would love to contribute to what I can. If anyone's doing that stuff, then please come and talk to me. And there's some more stuff on that page, the other architecture and like what versions I tested and stuff. So in the future, well, RSA key generation, I actually shipped that last week. MLChem is another kind of thing which quite recently, like in the last year, has become a necessity for really doing TLS on the internet. So I'm going to work on that. I'm probably going to take a dependency on it because there's a really good crate which is formally verified, really good performance, and I don't really think I can actually add anything to that. So I'll probably take a dependency on that at the Russell's Graviola level. And then I'll probably think about other architectures, try and come up with an even more demented way of addressing that. So yeah, that's kind of summary. I would say like give it a go. It comes with a general like. You should have a little bit of concern about adopting a new cryptography library. I think this is good, and you should, listen to your body. But I think I would really appreciate like any early feedback, like how it works for you. So yeah, thanks.
All right, Joe, thanks so much for the talk. It was amazing. We have some time for questions, so raise your hand if you have any question. Yes, we see one here.
Hello? Yay, nice. Man, I'm so glad this talk exists because like once every 5 years I have a chance to in Chile to hear someone as good as you. Thank you so much for it. Okay, I have a couple of questions, but this is the one I want the most, I think. So it's a bit long, but how do you cope, and how could one cope with the daunting task that is to implement a cryptographic algorithm? Because the math is kind of like paperwork, right? It's not exactly impossible. And I'm only being half facetious here, just have to put in the time and effort to get good at the math and understanding cryptography and so on and so on, to understand what assumptions to make and in what context a scheme is secure, right? But implementing them, however, to me feels like it entails an unbounded scope of possible failure points and edge cases, and I stay as far away as I can from implementing cryptography because of this. So how do you still retain your sanity?
I think that's a bit of an assumption on your part, but
fair enough.
No, to answer the question. So, firstly, I'm going to say that there's this like phrase "standing on the shoulders of giants," and S2M Big Num has done an enormous amount of work. Like, I maybe underplayed it here, right? This is like 100,000 lines of assembler per architecture, 500,000 lines of proof per architecture. This is an enormous and like highly huge scope project, and so that has given me like a pretty stable base to do the high level things. I would say the level in terms of like complexity of S2M Big Num is variable. It goes from almost exactly what you need. You may have noticed on the key exchange performance that the key exchange performance of Graviola is exactly the same as AWS LCRS, and that's because it provides that operation as a whole operation. So you don't need to take parts and glue them together like you do with like RSA and ECDSA. So, yeah. I think maybe I've not completely answered your question, but I'd say like this is a quite modest scope project in the sense that I'm taking something amazing and making it easy to use in Rust and filling in the gaps where the thing that is amazing is quite low level and not useful on its own. The other thing I want to say actually is there are lots and lots of cryptography implementations, and once you've studied lots of these for a while, you get a good idea of which ones you should go and read, and which ones you should go and read and point and laugh. Well, not point and laugh. That's really mean. But you know, which ones are good and which ones are bad. And you can learn a lot from studying other implementations. That's what I'm going to say.
I have a question. So for MLChem, I'm presuming that you would take the Jasmine implementation, right? So my question is, for all of this assembly code, how do you actually model the behavior, and how do you formally verify its properties?
Okay, so the first question, I actually plan to take the libcrux MLChem implementation. That is formally verified. Some fast paths of it, like they have an AVX2 implementation, which I think is still pending being formally verified. But like they are working on that, and it's the whole of like libcrux is a really interesting project if you're an enjoyer of formally verified cryptography in Rust. The other part, I think, is mostly a question about S2M Big Num. I'm not a great person to talk about that, but I can give you like a very poor description of what they do. So it's basically, they have some assembly and a proof. They have a instruction by instruction simulator for the semantics of those instructions. And then they have a big load of OCaml, which basically proves that once you've done all these instructions, that the inputs and outputs have this relationship, and the relationship is like these two numbers have been added together. So it's an equivalence proof, effectively, written in a high-level way and then a low-level way.
Time for one more question?
I think we have time for one more, yeah?
Okay. You had this great illuminating slide with all the crypto implementations and all the stars, and I noticed that you had more stars for Ring than for AWS LCRS, and still AWS LCRS is the default in Russell, so what gives?
Which column are you talking about? The assurance one, or?
No, like the total stars across all the columns.
Oh, right, okay. Can I refer back to that? Oh, there's lots of slides. I have far too many slides. Okay, I'm not going to get the slides back, but at least I can refer to it on my screen here. So I think AWS LC is kind of losing in this completely artificial evaluation, mostly through build simplicity. And the kind of reason for that is just its architecture. So it's a Rust binding to libcrypto or some derivation of libcrypto that comes from the AWS LC project. Ring is not that. It doesn't have that architecture. It's like fundamentally a Rust project which uses some limited parts of assembly and C from Boring SSL. So it doesn't like take the whole of Boring SSL, build it, and then start calling into it. And I think that has here we are. That has made it easier to make the build simplicity better. It's still not perfect. You still needed like a C compiler, but that is moderately easy for most users, I think. So yeah, did that answer the question? Thanks.
We have time for one short question. Hold on.
Oh, hello. So if I understand correctly, you use the STN big num as a underlying, and then you do the dynamic binding to the Rust, right?
Yeah.
And my question is, actually, I do a similar project, but my case is like a C++ binding, CXX. But I'm curious about why, do you have an opinion about rewriting this like a C++ library so that you can just like have one full Rust? Because I'm considering that. I know that the like underlying C and C++ library have a mathematical optimization embedded, but like could also rewrite everything in Rust, which makes actually more easy to like profile by using like a one same tooling, because I'm having really trouble in terms of like memory profiling in my setup like C++ Rust.
Yeah.
So I'm curious about your opinion.
Well, I'd definitely be a proponent of like writing things in Rust first and then exposing them as necessary to like C and C++ users second. I think the other way is compromised in the fairly obvious way that you end up like going from a really nice language calling into a less nice language, whereas the other way you are writing an enormous amount of the whole problem in a nice language and then just dealing with the slightly more unsavory parts at the end. I don't know whether that answers your question. I think it's a generally good idea to. I would prefer to write things in Rust than consume a C or C++ library.
All right. Joe, thank you very much for your talk. I understood some of the words you said. I'm glad that you're in the ecosystem improving the security and safety of all of our code. Give it up for Joe. As for our next guest, we will do some quick preparation. That means it gives me time for one more Rust joke. but I'm not sure how much time we will have. It will be a joke about Rust macros, and I guess I have to expand on that first. I'm here all day. I actually have another one on the Rust async ecosystem, and I can't wait to tell you.
Just want to shake your hand in person. A reading blog.
I met you.
I guess
saw
only,
you a video, I guess.
A video? No, I did not.
Code
make a video.
Crafters?
Yes, Code Crafters.
They sent
yes.
it to me. They sent it my way. They sent a short clip of that to me where you mentioned.
Yeah, like they did me like in like a customer interview because oh, that's funny. Like I got an email like I was plowing through the interpreter challenge and it's an email saying, hey, you might be like the
All right, we're about to kick off the next talk in this room by our very guest, Martin Laurent. I butchered the French name. But anyhow, he comes from Paris and he lives in Leiden now. And he worked on research and he also did a lot of C++ work, C++ work, low-level stuff. Touching lots of legacy code. How did that feel? Are you fine?
It's really hard. It looks horrible, but yeah, you have to make it work.
Yeah. Cool. And you are gonna tell us a few things about DNA, and you take it from there.
Okay. Well, thank you so much. Yeah. So this is a bit of a change because usually I present at scientific conferences, so I can't really nerd about the code, but I guess now I can, so that's really exciting. However, I still have to show you a bit of biology so you know what's going on before bombarding you with some Rust. So like, bear with me for a second, you're gonna have to do some genomics with me. And in particular, I mean, I'm interested in the study of like a couple of proteins that are named transcription factors. And these proteins, they can bind DNA at a particular site. And this binding, it's probabilistic. It's not really a yes-no answer. It has some energetic constraints. So it's like maybe it binds here more than there. That's how you need to take this into account. But once that protein binds, then it expresses a particular gene that is located after that site. So we really want to, when we have a big sequence of DNA, we want to figure out where these sites are located and where these proteins are going to bind so that we can figure which genes are located after them. The problem is that these transcription factors, they don't have just one binding site. As I said, it was probabilistic. So all we can actually observe is a bunch of validated binding sites. This we know by experiment that this particular protein from this particular bacteria is going to bind to these sites. But from that, we can build a consensus and kind of have an idea of, yeah, okay, that protein recognizes more or less this sequence. But once again, it's probabilistic. So it's not like you can just apply an exact sequence, like string matching algorithm. You can't just write a regular expression for this or like do Hay-Ho-Korasik or whatever. So the question is, how do you find new potential binding sites for a known motif for which we have experimental data in a new sequence? And here it's a sequence that just comes out of the sequencer. It turns out the answer to that problem is actually older than me. It was proposed in 1993, and like that's kind of still something that is being used. And the idea behind it is to take the binding sites that have been experimentally validated and generate a count matrix. So you count at every position of that site the occurrence of the different symbols. Here it's DNA, so you have 4 symbols, ACGT. The original paper is for proteins, so that's generic over the protein, the alphabet. We'll come back to that later. But from that count matrix, you can generate a scoring matrix. Once again, it has statistical implications. I'm not covering them. It's just a way to score a particular symbol at a particular position. That's why it's called position-specific scoring matrix. How do you, with this scoring matrix, find new potential candidate sites? Well, you take your scoring matrix, you take your candidate site, and you just read the score that corresponds to the symbol at each position. So here the candidate site starts with a C, so I take the C score, then I take the T score, then I take the G score, and so on. I get all my scores, I sum them, I get a match score. This score, once again, has some implications, but we don't care about it. All I care is to compute these a lot, because I'm going to compute this for the entirety of the DNA sequences that I'm processing. So I need that to be fast. And as a sort of benchmark, I wanted to look at implementations that are out there. And to do that, I made a small benchmark with just like one cute bacteria, Escherichia coli, that is everywhere, and just like one single motif of 16 symbols that's sort of in the median range. And I took 3 Python packages, but before you flame me, all of them are under the hood in C. So like it's a fair comparison to relook at performance for these. And what you can see is that the performance is that, you know, we are in like megabytes per second. I mean, it's not too bad. And okay, sure, you can see that the fastest one, it takes about 200 milliseconds to compute for the entire sequence. So here maybe you're like, okay, you're over-optimizing something, but you need to take into account the genomic scale. Here I'm showing a bacteria. Bacteria have small genomes. If we want to look at a slightly more like larger organism, pluricellular organism, like completely randomly a crab, I don't know, then you actually have a genome that is 1,000 times larger. Here we're talking gigabytes of DNA. And usually you don't want to scan with just one motif, you want to scan with a database of motifs that are known. So this database is also large. That means that here, that's 6 orders of magnitude more computation than you need to do. So I did the math for you. That's over 11 days of computation, and that's really a waste of your tax money, because I would do that on a public cluster paid by your taxes. You can parallelize that. Sure, it's embarrassingly parallel. I could do multi-threading on my computer. That would still take a day. That's not ideal. And the reason it's not ideal is because actually the implementation for that is not super complicated. I mean, here it is. It's like, yeah, it's two nested for loops. And for every sequence position I'm going to score, I compute a score. And that score means for every row of my scoring matrix, I add the score for that symbol. That's actually a good learning exercise for bioinformatics students. You can really give that to them. And so here, indeed, what I did was I wrote it in Rust, but I'm hiding a bit of the complexity in the different types. We come to that later. One thing you can see here is that, yeah, the runtime complexity is OML, where M is like the number of symbols in my matrix and L the length of my sequence. That's not going to change. I'm not doing some mathematics algorithmic optimization. I just make the OML run faster. So we can really quickly talk about biological alphabet representation, because one thing I said was that the method actually works for both DNA and protein. And another thing is you don't really want to keep your sequence as a string, because a string, even if you do an ASCII string, well, it has a lot of characters that should not happen in DNA usually. I mean, DNA, it's 4, okay, maybe 5 characters if we have a wildcard. So let's have an enum for that. Let's write the nucleotide enum, and here I'm using rep U8, so like my enum is a bit smaller in memory. And I'm also explicitly putting the numbers. I'm not sure you need to do that, but that's just me being paranoid. And finally, I have like a default, which is the N, which is my wildcard in DNA. And I could stop here, but I'm just going to add a tiny bit more of abstraction by having a type, a trait that corresponds to a biological alphabet. And this trait has also an associated symbol type, which also implements the symbol trait. So maybe naming not ideal here, but like whatever. And also a constant k, which is the number of symbols in my alphabet. And I can implement that for DNA. Sure, now DNA is like a marker type, but that's going to help me for generating generic code. And then I could also define that for proteins, but I'm not showing you. And that means my sequence now, instead of being like a vector of bytes or a string, it's a vector of alphabet symbols. So I'm generic over the alphabet in my sequence type. And I'm also generic over the alphabet in my scoring matrix. But for now, it doesn't really come into account. It's just really used as a marker. I'm saying this scoring matrix was made for that alphabet. This means that now our scoring code, which had this signature, turns into generic code over the alphabet. So this has 3 results. One, we have the same code for DNA and proteins, which is like great, because actually that's not always the case. We have sequence validation in advance. So that means when you are processing data, we know that already we only have like the 5 symbols we care about. And we ensure the scoring matrix and the sequence are in the same alphabet, which is also sometimes a mistake, which is not great. And so how does Rust compare actually on our old benchmark? And that's really the Rust implementation I showed plus these couple of extra traits. Wow, it's so fast. I didn't do anything, and it's like already 10 times faster than C and C++. And so, yeah, congrats compiler team, I guess. I mean, I don't know who to thank, but like, thank you. Yeah, that's really great. I mean, because we took like an existing algorithm and just porting it in Rust and doing a bit of clever type declaration and so on seemed to have made it faster. And all the rest I'm going to do now is just added bonus. This added bonus is going to come in the form of AVX2 instructions. And here I'm getting into platform-specific code. So in particular, I'm going to use this gather instruction, which is an instruction that when you have a base, like some data located at a base address, and an index vector can be used to load multiple elements from that address using the indices from that vector. And so this you can do in Rust using like the SIMD intrinsics. My idea behind it was to use it to, at this stage when we are basically summing over the different symbols, to do something a bit like this. That's not valid, but like the idea would be, okay, can we get the scores for multiple symbols at the same time and compute multiple sums, multiple scores at the same time? So you can, but it needs a bit of like a funky sequence memory reconfiguration that I'm going to go over very quickly because you do not have to care about it. But the idea is that we take our sequence and we put it in a column major order matrix. And this matrix has a number of rows which correspond to our SIMD vector. Once again, not super important. And then to score, what we can do is that now we can load an entire row of our matrix and we can use our gather instructions to get multiple scores. And then we can compute scores for multiple positions at the same time. And in the end, we also get our final score matrix in a column major order matrix. That goes into there. I'm not showing the code. If you know SIMD, it looks exactly the way you assume. If you don't know, then you better don't look at it. One thing you notice, however, in this algorithm is that we have matrices that have a constant number of columns, because here K is a constant that depends on my biological alphabet, and W is the width of my SIMD vector. So both things are constant, which means I can make my constant dimension matrix. I could use the N algebra crate, for instance, but I don't need algebra, so I'm just going to do it myself. And boom, yeah, I just define a row that is under the hood an array of constant size, and I define a matrix as a vector of this row. So it has like cache locality, everything. And then, well, that's my alphabet. So now I can make my scoring matrix a matrix that is where the number of columns in that matrix depend on the alphabet. Or at least I would love to do that when that gets stabilized. So currently, if you try to compile this, you get an error, but I'm sure if you go to this other talk, you will get some information about that. Very nice. So for now, I'm stuck using the generic array crate. That lets me do basically the same thing, except I can't really use constant. I still need to encode my numbers as types, but that's fine. I can still do what I want to do. I can still get a scoring matrix that has a constant number of columns. So how do we compare now that we have SIMD? Yay! Well, now we are 2 orders of magnitude faster. So indeed, I can process gigabytes of DNA per second. 1.1 is gigabytes. And I didn't lie in my talk. So that's already like super good, because now that means, yeah, this analysis I was talking earlier about like looking at a crab genome, now I can do it in half an hour. Cool. And probably less if I parallelize. The problem is that that's me. I'm excited about Rust. Bioinformaticians are not there yet. You know, their favorite programming language is still Perl. So that's where we are. You know. So if you want to make stuff useful, you need to make it available in a language they figure out. And for that, you can do Python bindings. And once there, I'm not going to really go into detail, because, I mean, as everybody is using, we're using Py03. It's amazing. Go to the workshop if you want to learn more, I guess. Finally, I'm running a bit short on time, but I just wanted to see SIMD in Rust is so much more easier than in C. And it's easier for several reasons. First one is memory alignment. In SIMD, you usually need memory alignment. In C, you need to use either non-portable functions, attribute, or you need to do manual pointer arithmetics, and you end up with like these kind of things in your code. In Rust, you can just say, please align my type. Yay! So once again, a good thing from the compiler. Conditional compilation, well, same for C. We need to do a lot of things at build time to check, can we compile for a particular architecture, particular features. You need to write header guards everywhere. In Rust, okay, I have a couple of like conditional compilation things, but I can force the compiler to always emit AVX2 code, and that's not a thing you can easily do in C. And the final thing that is much easier in C, in Rust than in C, is dynamic dispatch. And here, I mean, in C, you either have to use an external library, which means extra dependencies. You need to read from like a platform-specific location. You need to use the CPU ID instruction to figure what are your current CPU features. In Rust, there is a macro for that in the standard library. So yes, thank you. So in conclusion, Rust for biology, I mean, I think it really has a lot of potential, in particular for people that are currently doing C and C++, and that has already started. There are like a couple of very high-profile tools that probably 5 years ago would have been written in C or C++, and that have been written in Rust, and now people are actively using them. But also for things like portable code, it's actually more important than you think in biology, when we have like clusters that are old and people that are running on Windows. Reproducible builds, dependency management, and so on. I will just say the ecosystem is not there yet. We have a BioCrate. Fun fact, it's actually the first open source Rust project I contributed to in 2016. But it really has not evolved that much. I can say that there is a lot that can be done in there that it's a bit lacking compared to, I don't know, BioPython, for instance. So there is really room for improvement, but the ecosystem is a bit behind. And finally, yeah, SIMD in Rust, so much easier. It's unsafe, so you need to do what you're doing. But I guess STD SIMD is coming eventually, and that will be occasion for a great rewrite. So thank you for your attention.
Thank you very much, Martin, for your talk. Also, thanks for saving taxpayers' money with Rust. Want to move to Germany?
I moved out of Germany, so but I was wasting your money already, so don't worry.
That would be another talk. We don't have time for that discussion today, but we have time for a few questions. So if anyone has a question, raise your hand. It's hard to see people up here. Yeah, there's one here. Yeah.
Do you have any idea why the C implementations are so much slower? Because if they're slower even for a single-threaded execution, then it's not just like parallelism. Are they just written poorly? Are they not utilizing SIMD? But even your implementation without SIMD was much faster. Do you have any idea what's happening there?
That's a good question. So they are not using SIMD, but even without SIMD, we are faster. So that's that's using the super optimized SIMD version. I tried to look at the BioPython one, which is not the worst one, but it's the one that is like at 10 megabytes per second. And I can't really say, because it's not that different from the one I showed earlier, like our Rust version, the native one. What it just does differently is that where I'm using a lookup table, it's using a switch. Is that the reason? Can really a switch degrade your performance that bad? I'm not sure. So maybe that's that, but that's the only thing that really looks different. Otherwise, it's still using like a dense matrix. It's still using the same kind of code, let's say. So I don't know.
More questions?
In the front.
Hi, thank you for the talk. You mentioned using AVX2 to accelerate. Have you looked at AVX 512?
I have not, because the Leiden University cluster is running on CPUs that are already 10 years old. So even AVX2, I have to explicitly request an AVX2 node if I want it. So AVX 512, yes, it's the future. I think that's not the most urgent thing for us in bioinformatics right now.
Thanks.
There's one more question in front.
One of the big problems in bioinformatics right now is multiple sequence alignment, and what you've showed is using one genome. But if we have multiple genomes and we're trying to, say, build a tree to see where a certain species originated from, would it be trivial to expand this method to multiple sequence alignment?
I mean, this one is clearly made for single sequence. In a way, it's like it's a way to do ungapped, pairwise, local sequence alignment. For multiple sequence alignments, you have other options. I mean, there are tons of methods basically developed. If Rust can help, I don't know, probably, because currently, I guess a couple of them are written in C, C++, whatever. The problem is always adoption of these methods. Like if you make a new one and you want scientists to get it, you need to properly benchmark and show, oh yeah, it's producing the same results, or at least results that are better on a biological point of view. So that's always a bit hard to do when you come from more like engineering background, because all of a sudden you're like, okay. And otherwise, you need to make a tool that does exactly what the other tools are doing. That's less interesting, but that's another option. And then you can convince people to use it just because it's faster. But here, I really went for tools that do simple stuff. I'm not trying to like build on a new method. It's really exactly a method that already exists. I just show to people that you don't have to wait for so long until it gives you a result, basically.
Right next to you, on the left side. I guess she also had that.
Hello. So I believe the scientific world is more like there's two paths of optimization. Like A is like with the Rust parallelization, like GPU, CMD, like more like system level of optimization. Another approach is like just make an efficient algorithm itself. So like I'm like having a hard time to prioritize like, because actually mathematical optimization gives much more performance, but it takes longer time. So to make that algorithm to be stable and then like make it working. But the system approach have a limitation on like how many limit that I can optimize on, but it's very easy to like add on it. So I'm just wondering like what's your like decisions or like time allocation, resource allocation on this thing? And just like a small question, like have you also considered like GPU optimization apart from SIMD? Thank you.
Yep, thanks. That's a good question. I will say probably for the nice mathematical optimization, there is maybe a bit less knowledge in that area. Period. When people are developing things, even the people that are developing high performance methods do not necessarily have like that background in bioinformatics. So that's actually something that can be harder, and that's why a lot of people just kind of do the heavy crunching. Can we just go faster based on that? Another reason is a lot of optimized, or by that I mean fast software we use in bioinformatics, they tend to be built on heuristics much more than like a nice, elegant optimization to make them run faster. And these heuristics are like a super big trade-off and a super big question about what you generate. Is it biologically relevant or not? And then people start getting into faith about what kind of parameters you need to use, because then it's like, okay, if I tune down this, it will run faster, but I may miss some things. So it's really hard when you have these heuristics. So that's why for me, I tend to just go like the systems optimization approach, where I just look at old software, and sometimes I see, okay, this part has been really coded like shit, but like we maybe just by fixing that, we get a bit of improvement. Sometimes it's 100 times, sometimes it's like 2, but like that's already better than nothing. Yeah.
Fantastic. Give it up for Mata. Thanks for your talk. And just a few quick announcements before the lunch break. If you have any allergies, go to the first bar closest to the entrance, and the lunch is downstairs. And we will be back for the talks at 2 p.m. So that gives you roughly 1 hour, 15 minutes for lunchtime. See you later.
You turn off the lights and then I start? All right. Can you hear me? Yeah. Welcome back. Good afternoon, everyone. This is now the second half of today. Before we start, I want to quickly highlight a couple of our sponsors. You know, sponsors make this whole thing work, and we are very thankful for LF Alpha, bronze sponsor. You can visit the booth downstairs, as well as Tandem Drive, also bronze sponsor, also having a booth downstairs. Thank you very much for supporting us. Excellent. All right, so I have the immense privilege now to introduce Kira. Kira has been my co-moderator at Eurorust last year, and it was fun. It was an amazing opportunity, a real pleasure. And she's also not only the moderator of Eurorust, but also the organizer of the Rust and C++ Cardiff meetup, or also known as the Dragons. I heard it's a virtual meetup, so you can tune in anytime. And I heard from Tim Janus that there will be one next week. Is that correct?
Yes, like a hybrid special one. Yeah, put up the event tomorrow, hopefully.
Going to be fun. So she's very involved in the community, and she's a wonderful human being. So please give it up for Kira and to talk about atomics.
Hi, everyone. Thank you for joining me. The next half an hour is going to be my attempt at a crash course in memory ordering. So, as mentioned, my name is Kira. I'm a software developer at Esri, and we build mapping software. I'm also, as Stefan mentioned, an organizer of an online meetup. As part of that meetup, we had a book club on Mara Boss's excellent book, Atomics and Locks. If you haven't read it, I would really highly recommend it. This talk is very derivative of what we got out of that content. That meetup for me highlighted how many misconceptions folks have about memory ordering. Even experienced developers who'd been coming to the meetup for a while still got muddled up, still got confused. I think this is a topic that a lot of developers struggle with or gloss over. So if you feel like you're guessing whenever you have to put a memory ordering down, or if you've just avoided them entirely because you didn't really understand what they were, then this talk is for you. If you're looking for a bit more of a niche, future-looking aspect of memory ordering, like consume ordering, then this talk might not be for you, might not teach you anything new, so I won't be offended if you switch tracks. We'll start with a little bit of background information, covering the very basics of atomics and lock-free programming. We'll then discuss some of the assumptions that we're allowed to make with single-threaded code, which no longer hold when you introduce multiple threads. We'll look at how memory ordering solves our problem case, and then we'll end with a laundry list of further reading, because this talk is only half an hour, and there is so much in this topic that you can learn. So do check those out if you're interested. So why use atomics, and what are they? Why do we care about atomics? Because most of us have machines with multiple processors, and we want to take advantage of those. Often that involves sharing memory between threads. This is mostly pretty straightforward, especially in Rust. It's fairly difficult to go wrong. You do your thread spawn, you throw your data in an ARC mutex that you want to share, and then take care to hold on for that lock for as little time as possible, and then you're good to go. If you're using mutexes for all of your shared data, then you don't need to worry about memory ordering. It's all handled for you under the hood, pretty much. But sometimes you're running in a really hot path of your code, and the cost of locking and unlocking that mutex becomes too expensive. So for a subset of data types, we can instead use atomics. Rust gives us access to these lock-free primitives, which are pretty basic: atomic bool, atomic U32, atomic U64, etc. And all of these we can update from multiple threads in a totally lock-free manner, provided our platform supports them. They're a platform feature, but they're exposed in a platform-agnostic way. So what do atomics give us? Well, as mentioned, they're lock-free. So they're guaranteed to be lock-free. If your code compiles, those atomic operations will be lock-free. And that means they don't require a global mutex. We also get no torn reads and writes. So when you've got multiple threads or multiple processes reading and writing to memory, we want to make sure that that write has completely completed before some other thread tries to read from it. Otherwise, we could have partially written data, which might be totally nonsense, and we essentially get undefined behavior. Atomics also provide these read, modify, write operations. So there's a kind of subset of operations that will be able to read from your memory, update the data, and then write it back, all in one single step. So again, there's no way another thread can get in there in between the read and the write and try to write some additional data. It's all done as one atomic, indivisible operation. And this is how that looks. You can read, modify, and write to atomics using member functions like fetch, add. So here we're reading foo, which we've initialized with 5. We're adding 10 to it and storing it back in all as one single atomic operation. To use any of these operations, you have to specify an ordering. And to understand why that's needed, which is like the whole point of this talk, we're going to need to go back to basics a bit and talk about the assumptions that we make when we write our code. We write our code to do what we want it to do. And there's an implicit assumption when we write our code that we want those lines to get executed, and we want them to be executed in the order we write them in. It sounds obvious, but we expect that when we run this, everything will happen one thing after another. In this case, we're creating some null data object, marking that the data has not been set using this isComplete flag. And then we're setting that data and then changing the isComplete flag to true. We read our code from top to bottom. That's the logical order of our code. But what happens after we've written our code is something else entirely. It gets compiled and it gets optimized to be more efficient. And the CPU might shuffle around instructions as well as it sees fit. So even though this is what we've written, that isn't necessarily what happens. But the compiler and the CPU will always make those modifications in a way that looks like our code ran the way it was written. The outputs of the code will be the same as if you had just run the code, just faster. You can think of this as like if a tree falls in the forest and no one's around to hear it, does it make a sound? The only thing the compiler and processor have to ensure is that the end state is the same. And that means some reorders are allowed. They're allowed by the compiler, they're allowed by the CPU. And that means this rearrangement of our code could happen. We've switched the order where we set the data to 7 and set the isComplete flag to true. When you get to the end of the code, everything is in the expected state. We've set the complete flag and we've set the data. Those things have both happened, but the order they happened in was different. Which is fine as long as this is the only code running, but when there's multiple threads in play, this no longer makes sense anymore. The role of that isComplete flag has totally changed. If we introduce a second thread, the data write order on thread 1 suddenly becomes important. If we've set the isComplete flag after we've set the data, we can use it to tell us that the data has been set. So we're relying on that flag on another thread. If we can switch the order, we can get into trouble. We can enter this branch and try to operate on our uninitialized data. So how does the compiler or CPU know that it's not allowed to do this? How can we tell it that this reordering shouldn't have been allowed? Well, without ordering, there isn't really a way to do it. We could imagine that we could tweak the code in thread 1 so that it does have an observable difference if we switch the order, and that might prevent some kinds of reordering. So here we're checking the value before we set the flag, which would in theory change the code such that there's not any rearrangements that the compiler or CPU could make to switch the order of the data set and the isComplete set. As far as thread 1 is concerned, the Boolean is only set to true after the data has been set. And you might assume that now all is well with the world, but unfortunately not. Here I have that same code, which has 2 threads. Again, starting with the data as null and the isComplete flag set to false. I've just changed it to an atomic bool to allow it to be shared. The second thread loops until the isComplete flag is read as true. And only once the isComplete flag is true does it check the data. And at first glance, it looks like this should always succeed. The data should always be set. But if I run it in a loop on my laptop, which has ARM under the hood, then the assert will frequently fail. So how is this possible? The thread only sets the flag to true after the data has been set. So how is it possible that the data is not there and not the value we expect? One way we can think about it is imagining our processor and some memory. Processor 1 is going to be our thread 1. It's going to set the data and then set the isComplete flag. Processor 2 is going to loop, reading the isComplete flag until it reads it as true, and then it's going to read the data and do something with it. So first, we write our data, then we set our isComplete flag, and we're looping until the isComplete flag is true. So we know that this has already happened by the time processor 2 reads the data, because it's set to true, so processor 1 has set it to true, therefore the data has also been set. With this super simple model, it doesn't look like anything can go wrong. But let's say we introduce a cache. The vast majority of CPUs have caches, so this is a pretty reasonable update to our imaginary, pretend, oversimplified CPU. Suddenly, we're not necessarily writing the data and the isComplete flags directly. We might instead be first writing to some intermediate cache, so we can call that data prime and isComplete prime. And those writes happen in the order we expect, but they still need to make it from processor 1's cache to the main memory and into processor 2's cache. And this cache synchronization is totally divorced from our processor order, which means the isComplete flag being set to true could in theory now be read by processor 2 before the data itself is available, which could cause the bug that we saw earlier, that when I ran that code on my machine in a big loop, I got that error. This is the kind of problem that we're trying to solve with memory ordering. So is this how the processor actually works? Is this really the problem? I mean, our imagined CPU there is really simple. Real CPUs are complicated. They may not read individual variables. They might read full cache lines instead. They might reorder the reads and writes in some other way to happen efficiently. Each processor might handle this slightly differently and provide different guarantees about how our data gets synchronized. That code that failed on my machine could very well succeed on yours. Ideally, we don't want to have to know anything about how our processor actually handles memory, how many caches it has, how it synchronizes those caches. But what we do want is for our code to be correct. And for our code to be correct, we need to know that these types of reorders can happen, regardless of why they might happen. Our current best attempt at describing how machine memory behaves generically is the C++20 memory model, and that's what Rust uses. It's very similar to the C and C++11 memory model with a few tweaks. And what it does is it lets us reason about our machine and constrain the behavior without knowing the details. It creates this abstraction. This is from the doc. It defines the semantics of computer memory storage for the purpose of the C++ abstract machine, or in our case, the Rust. It boils down to this. Out of the box, we have no guarantees about the relative order of different variables we're updating. We've seen that why this might be the case with our imaginary CPU with the caches, but we don't need to know exactly why. We just need to know that it can happen, and we need some way to prevent it or constrain it. This is from CPP reference. One thread can observe the values change in an order different from the order that another thread wrote them, which is what we observed earlier. We need a way to write our code so that if we read the isComplete flag as true, then we can be absolutely certain that the data was set and that we can read from it. Fortunately for us, we can use memory ordering to do just that. It allows us to create a relationship between the write of the isComplete on one thread and the read of it on another, to ensure that the other data in play has been updated to be consistent with what we expect based on the way we wrote our code and the value of the isComplete flag. We want to know that if we read isComplete as true, then when we read data, it will definitely have already been updated as well. So for that, as mentioned, we use memory ordering. This ordering parameter on store and load gives us a way to describe the relationship between two threads storing and loading the isComplete flag. We fixed it by changing our relaxed store of isComplete to have release ordering, and changing our load of isComplete to have acquire ordering. So let's look at what that means and why it fixes our particular problem. CPP reference says the following about release-acquire semantics. If an atomic store in thread A is tagged memory order release, and an atomic load in thread B from the same variable is tagged memory order acquire, and the load in thread B reads a value written by the store in thread A, then the store in thread A synchronizes with the load in thread B. That's quite hard to parse if you're reading it for the first time, so let's break that down. If thread A stores isComplete using ordering release, and thread B reads that updated isComplete value using acquire, then thread A synchronizes with the load in thread B. Now, it's important to say what this doesn't mean is that thread B will necessarily see the update from thread A. All it means is that if it sees that update, then it's going to synchronize with it. If we read the isComplete flag on thread B and it's false, then that means that we didn't synchronize with thread A. If we read the isComplete flag on thread B and it's true, however, then we did read the value set by thread A, and so we synchronize with thread A. Okay, so I've said synchronize with without explaining what synchronize with actually means. What does synchronize with mean? Again, let's take a look at CPP reference. It says that all memory writes, including non-atomic and relaxed atomic, that happened before the atomic store from the point of view of thread A, become visible side effects in thread B. If thread A has seen some other memory changes at the point it synchronizes, then thread B must also see those changes. You'll hear this described as a happens before relationship. So now we've fixed our code. Thread A sets the data and then stores true in the isComplete variable with release ordering. Thread B loads the isComplete flag using acquire, and if it reads the value that thread A set, which we know that it does here because it's in a loop, then it synchronizes with thread A. So that means when we synchronize, we get access to all of those data updates from thread 1 that happened before the corresponding release. So I'll leave that up for a second just for people to read it, but that's essentially our fix. A helpful way to think about whether or not release-acquire semantics what are needed in your case is to think about what variables in your code can be reordered and still have it make sense. A release store prevents previous memory operations from being reordered to after the store, whereas an acquire load prevents subsequent memory operations from being reordered to before that load. In our case, we require the data to be written before the isComplete write happens. Reordering the data set val call to be after the isComplete store breaks the logic of our code, so we have to use release to prevent that reordering. On the second thread, we require that the data read val operation happens after the load of the isComplete flag. And that's the whole point of this flag, is to tell us that the data has been updated. If we reordered the data read to be before the isComplete flag, then our logic doesn't hold because we're no longer checking the flag. And we can prevent that reorder using acquire. We've essentially enforced the ordering that we had in our simple cashless CPU earlier. On processor 1, the data store can't be reordered to after the isComplete store, and on processor 2, the data read can't be reordered to before the isComplete flag is read as true. Some operations do a load and a store in a single step, so things like fetch add, which we saw briefly earlier. In those cases, you might need to supply acquire release in certain cases, which does kind of two things. It ensures that the load that was used has acquire semantics and the store that was used has release semantics because we're doing read, modify, write. There's a read there and there's a write. So you're going to have acquire and release. The impact on reordering is the same, only now we might observe acquire and release synchronization behavior in one step, but they still need to have paired loads and stores on other threads for that to make sense, for that to be needed. So that's acquire release, so you can take a breath. These options allow us to prevent reordering by synchronizing a release with an acquire. If you have a release but no acquire, then there's nothing to synchronize with. It also only makes sense if there is other data to synchronize. In our case, we're synchronizing the store and the load of the isComplete flag to ensure that the memory we wrote is going to actually be visible to us. Ooh. But sometimes acquire release isn't enough. And here is one of those cases lifted straight from Marabus's Atomics and Locks book, which again, you should all read if you could get anything out of this talk at all. So let's walk through it. In this code, each thread has its own guard, A and B, for some string S. We initialize our guards A and B to false and S to be an empty string. Each thread checks whether the other thread has locked the string before writing. If A is true, then thread A is trying to update our string. If B is true, then thread B is trying to update our string. If we're using release acquire semantics, like we are here, then we need to think about what that means. It means when we store true, we release all the memory operations that happened before it on the current thread. But like, if we look at our code, nothing happened before it. Nothing happened before those stores on the current thread, so it's not really doing anything. And ditto with thread 2, again, that release isn't really doing anything. So can these two pushes ever occur simultaneously? Well, potentially, because A and B are essentially independent. With sequential consistency, they're no longer independent. We get a single total modification order for all of the atomic variables operations that are tagged with sequentially consistent. So what does that mean in practice? It means that both threads have to see the same thing. They have to see the same order. Either A was updated before B, or B was updated before A. There is no way that one thread could see A being set first and then B, while the other thread sees B being set before A. We have some sequentially consistent order across all of our threads that are using this sequentially consistent ordering. This is a much stronger requirement than the happens before relationship of release acquire. And it typically doesn't make sense to mix and match release acquire with sequentially consistent. It becomes much harder to reason about it if you do. But if this is your requirement, if you need all of your variables to happen in a very, very specific order, then sequentially consistent might be what you need. You probably don't, but just in case you do. So do I always need at least acquire release or something stronger like sequentially consistent? No. If I only have one single piece of shared memory, like a counter, then you only need relaxed memory ordering. The other memory options relate to the order of updates to different pieces of data. If there's only one piece of data, the atomic itself, then there's nothing to order with. Even if you do have multiple pieces of data, but they're independent, then again, there's no need to synchronize with some kind of stronger ordering. This might be obvious to some, but I think it bears spelling out. Ordering is only important when there are multiple shared variables with some implied dependency between them. And again, it's worth noting, single atomic variables are still really useful, not least because they are actually completely self-consistent already. Every atomic within itself has a single total modification order. So if I have some atomic and it goes from 0 to 7 to 10, back to 0, many, many operations, every thread is going to observe that same order. It's only relative orders for different data that can vary without synchronization. This is what we were preventing here. In this case, thread 1, the data goes from 0 to 7, and is complete goes from false to true. On thread 2, the exact same thing happens. The data goes from 0 to 7, and is complete goes from false to true. It's only the relative order that we observe those changes that's different, and that's what ordering was protecting us with. So relaxed is fine in many, many, many use cases. I wanted to give just an example. If you take arc clone, this uses relaxed memory ordering. This is a very simple example. There is no synchronization that needs to happen with other threads when we're modifying the strong reference count on our arc using clone. Having a single total modification order and the knowledge that there is always at least one other reference, because we have a reference in order to pass it into clone, that's enough. There's no happens before relationship needed. The data inside an arc might be a mutex. We talked about that at the start, how common a pattern that is. And if you're using a mutex, you have already secretly been using release acquire semantics without even knowing it. The lock acquires stores from whoever held it. The unlock releases the current thread stores to the next thread that locks it. Similarly, with thread spawn and join, you don't need to worry about data on the current thread not being visible to your spawn thread. We implicitly have a happens before relationship already. The semantics of mutexes is one of the reasons why it's rare to see issues with memory ordering unless you are also writing unsafe code. Sharing data between threads requires either a mutex or some equivalent wrapper type or unsafe. To be correct, the mutex or equivalent wrapper will already have the kind of release acquire or sequentially consistent, probably not, but release acquire semantics needed to correctly guard your data. And that's ordering. Release acquire creates a happens before relationship between stores and loads on different threads. There are examples where release acquire isn't enough, but they're not very common. We looked at one where we need sequential consistency, which has all the same guarantees as release acquire, but it also creates a total modification order between all the sequentially consistent data. And relaxed has no ordering guarantees, but it does have all of your normal atomic guarantees, such as being indivisible and a single total modification order. So what's the TLDR of this talk? Memory ordering only matters when there are multiple shared variables. And if all your code is safe, it's fairly unlikely you need anything more than ordering relaxed. But you can use reordering operations to reason about what kind of ordering you need. Can the previous stores be reordered after? Can the next reads be ordered before? And you can use that to decide whether acquire or release are appropriate. There is so much online and so many resources available kind of on this topic. Mentioned a few times, Mara's excellent book. I would really highly recommend it if you found this interesting. There's also a series of blog posts by Jeff Pressing, which Amanya, who authored Parking Lot, amongst other things, recommended to me, kindly pointed me at it, and I found them really, really interesting. They're looking at it from a C++ perspective, but all of the content in there is completely relevant to Rust. There's also the Crust of Rust, John Genset's video on atomics and memory ordering. It's 2.5 hours, but it's well worth a watch. And then there's also things like the C++ standard, the CPP reference. There's tutorials. You can dig into reference manuals if you get really hardcore into it. Don't necessarily recommend that. You don't have to. The Rust documentation alone is enough for most people. But yeah, so I hope you enjoyed that. That is everything I have, and I think I'm about at time.
Thank you so much, Kira. Amazing talk, lots of information, lots of stuff to catch on to. Are there any questions? So there's a hand up there. Sorry, next one. And also up there, apparently.
Yeah, so I was curious because the talk has been focused now on the semantics, as in what do I require of my code to do what I want it to? But is that the only consideration for what memory semantics make sense for you? Or, because I presume there's an overhead with the different memory orders. So if I'm just having acquire release, do I just use an arc mutex, or should I be keeping in the back of my mind overhead with the different memory orders?
I would say correctness is the most important thing about your code, and if you're not using unsafe, then probably relaxed is fine for almost all of your use cases. If you're worried about the performance, then, which I assume you are, if you're using Atomics, you probably care about performance. But Atomics, if you're just doing something like a counter, then you shouldn't be kind of put off by that. Yeah, the performance implications it will be completely dependent on how your code is structured. So it'll depend. But I would say don't worry too much about the performance unless you're actually measuring a problem with your performance. But also don't do sequentially consistent just because you think it's going to be right. Reason about your code. Think, is this correct? What I'm writing, does it make sense?
In other words, be relaxed about it.
Yes, be relaxed.
Great. We have another question in the first row. Box coming up. Cool. No interest so far. Great.
So I was wondering, in the first example that you fixed with release acquire, you still checked the value of the data that you wrote before you set the is complete. Is that still something that's required?
No, that's absolutely not required. Yeah. Left it in there to kind of demonstrate the point. The reason that check is in there is to prove that that kind of change is not enough. That was the reason behind that, but it's absolutely not required. Because that's the other thing that acquire release is doing, is it's describing that relationship.
Thank you.
Okay. Any more questions? Over there. Good morning.
Cool. Hi, great talk, thank you. My question is, in the first example, does the acquire and release also guarantee that thread 2 will eventually read the updated value? Or does it just guarantee that if it reads the updated value, it sees all the other stuff that happened before?
My understanding is, the latter. It's only if it reads the updated value and that updated value has come from thread A that it synchronizes with thread A.
Right, so it could still happen that the thread 2 just loops forever if the value never propagates from the cache of thread 1.
For sure, yeah. And in practice, that won't happen, right? Otherwise, but in theory, your thread could never get scheduled, and there's nothing in memory ordering to stop that happening as far as I'm aware.
All right, thanks.
All right, I think we have time for one more question. Let's see if there's a hand somewhere.
I also have a question from the YouTube chat.
Oh, cool.
Philip is asking, how does reordering work with interactive debugging, like with GDB?
Sorry, could you repeat the question?
How does the reordering interact with interactive debugging, with like GDB and stuff?
Oh, interact with debugging. I mean, it's no different, I would say, to any other kind of like optimization. The thing that's causing debugging to be difficult is not the memory ordering; it's the compiler doing strange things. So I don't think there's any special considerations you need to think about.
All right. So if there aren't any more questions, let's have a look around. Then I would say thank you very much, Kira. It was an amazing talk. Wonderful. Please have another round of applause for Kira. We do a quick stage change. We will be back in around about 10 minutes at 2:45 with Martin. All right, cool. So I try to soothe my voice after hearing all that smooth jazz coming from the speakers. It's still going on, cool. Welcome back, everybody. Welcome back to the second talk of the third block. So we talk about refactoring, eh?
Yeah, we do, Stefan.
Cool. So, all right, please welcome with me Martin Kooi. Martin Kooi has been, he's a local, first and foremost. So he's from the Netherlands, and I assume, it's just my third day in the Netherlands ever. I assume that no matter where he's from, he's a 30-minute train ride away.
That's correct.
It's correct, isn't it?
Yeah, it
cool.
is.
And Martin has been previously a researcher, and now he leads a Rust team at Roxys.
Yes,
yeah,
I do.
And Martin has 4 children, and none of them followed you into programming.
No, so I'm so happy to be here and talk about programming with you. That's why I'm here.
Great. So let's listen to Martin. Please have a big round of applause for Martin.
Hi, yeah, you introduced me well. I was in computer science long time ago. I've been in some management functions, CTO offices, self-employed work, but now I was thinking when Rust came up, I need to change my path and go back into languages, language designs, working with the people, go back to a team, and I'm the happy team lead of an embedded software team in Roxys that works solely in Rust. So here it's okay, but on other talks I sometimes say, if I look biased towards Rust, you're correct. So, short plug on Roxys. We make robots for hands-free, effortless charging. We have a complete platform, robots, APIs. We work charger neutral, and the control software that's interesting for here is mostly Rust. We do that on Yocto Linux. We also have Rust completely embedded on the bare metal. We use Embassy for that. And if people press me in a corner, yes, we also have some Python and TypeScript running around. So we're in the cinema today. So let's have the full cinema experience. In the beginning, there are some teasers. We will have a short documentary on Rust. We'll have the drama, because I'm not talking only about the technicalities of Rust, but also about the people effects of it, managers and people, and of course the bloopers, which are mostly held for the management aspects for it. So let's do the full cinema experience together. Yeah, so traditional fears in refactoring. Before we start that, has anybody any idea where most cost in the software lifecycle is placed? Well, to give away, it's not during development. It's in the years after it's been deployed, the MVP has been deployed. There are product owners that want new features, customers that want new features, bugs that arise that have to repair. A lot of the costs in software development life cycles are after development. So what do we do in the development? We often do some refactoring, but we've all been there, I think. It gives fears. Why? We have this fear, don't touch it, it's not broken. We have some change apprehension. If I look at the daunting effects of changing the code, hidden stress that it gives, because maybe I'm forgetting something. I'm working with other people's code. Or even worse, I'm working with my own piece of code, but in the future me. I don't know why. Why? What dependencies? What smart ideas did I have long time ago? When I do the announcing, I work around existing code. I try to add on top of the existing code, because changing the existing code is dangerous. Maybe it fall down. Maybe there's one of these pillars there that I took away because I can't remember why I built them. And then, of course, suddenly I find out why. You have active rotting. It gets more and more difficult to change. Yesterday, I had lunch with someone, and he said, well, you know, this this piece of software called Finale. It's used by music. My son is a professional musician, and he uses that software to write his music, his sheet music, and it's been abandoned. They can't change it anymore. You can use it, but there will be never any changes, just too difficult. So, how does Rust help? Preaching for the converted here, but maybe you are in a company and you need to explain why Rust is okay or better. Well, it has a lot of language features that safeguards you from the many, and I put it in quotes here, small errors. The errors may be small, but the consequences can be big. And I won't sum them all up. You most know them: enums, matching, lifetimes, mutability, concurrency, avoid special value semantics. I love that also about Rust, the option. A value can just be absent. In many other languages, we are forced to take a special value, like 99. Will I remember next year that 99 was special? Or maybe I come in a circumstance where 99 actually was a normal value. -1, that's another very famous one for error or something. There are no nulls. And of course, we have a consistent ecosystem that really helps to be the same every time you use it. Enums and matching, I have this very bad example, but that's good because it was code I wrote myself. So, but if I add it, it's kind of made simpler, but added from a real example. If I add a state, let's say operational moving from my robot, if I have the match statement, I will immediately get these red squiggles to alert me for the fact that I didn't put any code for that case. So using enums in a way, and match statements, really helps you. Of course, did you see the posters here? Out? They're so fun. They're so good. I have to compliment the creativity of it. And of course, concurrency with atomic reference counting and reference counting. If I use a reference counted element in my code, and later on I'm refactoring and I'm thinking, let's do this in another thread, then I will be immediately pointed to the fact, hey, reference count, it cannot be sent safely across threads. Please use ARC. Very helpful when refactoring. You don't forget all these small things that add up to big errors. Of course, I saw the arc coming up here as well. So what are the effects? Actually, Rust helps me to read my code later on. Rust is not a write once, read never language. It's a readable language. It helps other people to read my code or other people's code and safely change it. Even if I didn't know about the operational moving, the red squiggles would have told me there is code to be added there. And in the L, it means it's easier to switch teams and to have new hires. I've really seen that the same in our team. We had a new hire. They could work in the team within a month or so, without too much explanation. It's all the same. Everybody knows cargo. Everybody understands Rust. The code base is transparent. Yeah, well, then I also hear when I do the hiring, fighting the borrow checker that's out. I like to think, and that's a compliment to, I was also do the compiler front-end presentation some, I think 1 or 2 hours ago. And I have to compliment it. I love the compiler. If there are errors, yes, they're nagging me, but they're telling me why and what did I do wrong. I like to see the compiler as a big help as well. So now, this is technical, well, semi-technical part of it, but it has effects on the people. Because why are you a developer? Anyone know? Anybody get the greatest time from debugging? Yeah, if so, please it's not a judgment call or anything, but many people I speak, well, some debugging is fun, but chasing a memory leak for 3 months, yeah, you're happy you found it, but they're not the best 3 months of your life. Then technical debt. When you make a shortcut, you often know you make a shortcut and think, oh, maybe I need to refactor later. Do you go to your manager and say, yeah, there's technical debt, we'll put it on the backlog? And your manager says, yeah, okay, we'll put it on the backlog. What happens with the technical debt on the backlog? Okay, yeah, I got here, there is never. Well, it's there. So, also, that means that sometimes you are a bit hesitant to push out your code because you know if there's technical debt in a code, I will never get the time to repair it anymore. So satisfaction of your work is actually higher with Rust. Also fear reduction. The next feature. Previously you had to work around. You have to work around your old code. You have to cheat or grind through all this rotted code. But refactoring in Rust is actually quite safe. If I refactor something and it compiles, it will probably do exactly the same. You just do, what was it? Type, Stefan. Type trade, and everything is okay again, and readable. And you never have to ask the question, why does it take so long? Well, the real answer is, of course, I'm hiding all my future refactoring before, dear manager, you put it on my backlog. So I think, and there are some people in the team here in the here today, and I think they will say they're happier people because of Rust, but we will probably have to ask them themselves. Management effects. Well, I don't want to skip this one, but let's start with the most important thing that managers talk about, and that's money. Fearless refactoring, it brings down the hard costs. I put an asterisk there because this is my own calculation and I do not have, and I was thinking that in Rust we do not have enough measurements yet, but I saw some talks from internet sources, from Volvo earlier yesterday, from the Android project. We start to collect measurements. Please do that because this will bring us to safer grounds in saying what I said before. Development, basically the same. Unit testing during development, much quicker. During maintenance, goes down by 50%. Upgrades, inclusive to refactoring, are 30% cheaper than normal upgrades. So if you make the total cost calculation, Rust is about 2/3 of the price of any other language I know. Anecdotal proof of that, it's not real proof, but I've managed a lot of technical teams. We did, the last 2 years, with 4 people in the team, work for at least 6. I would normally have hired 6 people. So for management, this is compelling. And am I the only one who says that? Well, it happens to be, this was already in the presentation, that my dear master of ceremonies, Stefan, I picked up an old YouTube video. So I'm not the only one telling
this. 3 or 4
this.
developers. With Rust, we were able to write much more stable software. They were rarely confronted with maintenance work, which allowed them to actually work on features.
So it's not only me saying it. I could have called you today, but I thought having this is quite fun. But there's an effect on management as well, because if management doesn't change its behavior, we will be nowhere. So I think with the other big cinema picture, it should be let it go. Let it go. Allow people to refactor little bits to prevent rot. Remove the fear for, what did I do? Remove the fear for technical debt. So also as yourself as a manager, allow for it. Walk the talk. So I used to be that manager. Hey, it's not broken, don't touch it. Because I knew the costs of people trying to touch all the explain. I go as a manager from, hey team, we're not going to touch the code when it's not broken. I go to, hey team, let's prepare our code for the flawless next step. And also, hey team, we need to ship, stop coding now. We will put the technical debt on the backlog, which is basically, when I had to do that, it always felt like lying. Because I put it on the backlog and really I knew I would never give time and money to do it. I have to change the behavior, but it's possible now. Hey team, we need to ship, stop coding. Next time when we have the next feature, we will do the refactoring before we start the next feature. And actually I gave this talk earlier and Jochem put on the LinkedIn a summary of my talk that I couldn't have made myself. So thank you, Jochem. Make the change easy to make then the easy change. And I thought this was a great way to summarize what's happening with fearless refactoring. So, fearless refactoring. The fun goes up and the costs go down. How good could we have it? So I hope this also helps you in your company or wherever to say, yes, we go to Rust. We will have more fun and we will have less costs. Thank you very much for listening.
All right, thank you so much, Martin. Do we have some questions? Maybe we can get the lights up again?
Yeah, is there light?
No,
in the
already
cinema?
running. Give me a second, then I can see who's raising their hand. Okay, over there, we have one in the 4th row, I guess. Perfect, good catch.
Hello?
Hello?
Hi there.
Hi.
We are relatively a large company where some of us are trying to adopt Rust in our company. Sometimes when we mention about it, an answer we get is, but Rust is hard to learn.
Ah.
What do you think about that?
Mm.
And thank you for the presentation. I think it was very nice.
No, thank yes, I have a very personal opinion on this and I hope I don't offend anyone. But if you are a good developer and you've struggled some years with C and C++ and memory pointers and objects not being there when you expect them to be there, I would say Rust is not difficult but helpful. But this is my very personal opinion. Just hire the right people.
Right. I always see if I can learn it, well, it can't be that hard. But yeah, do we have another question in the audience? Let's see if there's some hands. Over there, first row on the right side.
Throw the box, throw the box. Yes, good catch.
Hi,
Hi.
no booing and hissing, but I'm a manager.
Oh, sure, poor you.
Do you think it's, if you've got an old product which is in C, do you think it's worth having a parallel product in Rust?
Now we go into the business cases of sunk costs and lost investments. Of course, you have to do the calculations right. Mostly the answer is no, because an existing project brings some money. the costs of rotten code can be quite high. So yes, there is a business case for it, but you have to find the business case and defend it till the end. And it's not easy. And sometimes you just have to also, there are products that are out there that have their software, so don't take on a lost cause. That would be my advice.
All right. Any more questions? Do I see some hands? Over there, first row in the middle. Second row, sorry. Cool.
Wow. we can do the basketball here. That's it.
Well, I even have my glasses still, so. You showed a few features of the Rust language that help you there.
Yeah.
Did I miss the data flow checks? Because from my personal experience, refactoring, it also, the compiler helps you by finding the dead ends. And after refactoring, some ends are dead. So you just delete them.
Yeah.
But did you mention that? Or
no, I didn't. To be honest, I forgot about it. And actually, I was pointed out today, I forgot another one. Let's put it this way, and protect myself, I ran out of space.
Good, thank you. Where does this go?
No slides left anymore. Yeah. All right. Do we have some more questions? Let's see. We do still have a little bit of time. But yeah, if we don't, I guess Martin will be here for the rest of the day, so you can catch up on him and discuss everything about refactoring project management. So the Managers Anonymous are meeting outside at 4. And one thing that I wanted to say, to me, it's really funny that the software for musician that has been abandoned is called Finale.
Yeah.
So they kind of had it coming.
Yes.
All right. So, and with that, we're doing another break. I guess we continue with the schedule at 3:30. So we have a little bit of a longer break right now. And then we're going to watch comics with Valdemar. So looking forward to that. So see you back at 3:30. All right, welcome back, everybody. This is now the last talk before we go into a bigger break, before we have the last block of the day. And I'm happy that we can welcome Waldemar Erk today on stage. Waldemar is the co-maintainer of the Discord bot libTwilight. And he told us that he lives inside of Emacs. So I'd say I hope I get that right, CXCC him back into Utrecht, into room number 12, and have a big round of applause for Waldemar.
Thank you. So I'm going to talk about Garfield's worst nightmare. So there's a few prerequisites. Oh, we come back. Okay, yeah. So I have a Discord bot. The only important thing it does is it posts a Garfield comic every day, because they're still published every single day. So it does that. It doesn't really do much else. Like a bit more, but not much. So to get the Garfield comic, it would be nice if you just had an API. You could like say, give me the Garfield comic, but of course you don't. So GoComics is the official web syndicator of Garfield, and they have a fine website. So what I do, I fetch the website, I get the URL for the Garfield comic, and then I save it in a database so I don't have to fetch the website again. The URL is pretty small. I actually only save there's a hash part of it, some kind of hash from the CDN, and I save that, and I can reuse it every time. So I just use the URL directly. The database is keyed in the Garfield epoch, which is day since the first Garfield comic, which was what I thought made most sense. So today is like day 17,131. This is of course a better epoch to use than Unix epoch, but people are using the other one anyway for some reason. So on the 12th of October last year, it was a normal Sunday. The Garfield comic posted the comic it always does, but I immediately knew something was wrong. Like you can maybe see a bit why it's wrong when you look at the date stamp in the third image, because this is the Garfield comic for the 11th September 2001. That's a pretty unlucky comic to post. So why did that happen? So that's a good question. So the first response, I deleted the database. It's an on-disk database. So I deleted that and I restarted the bot. I tried to send comic for today. That worked. Then I sent the comic for the 11th September 2001. And it showed the comic for today. So the issue still exists. So why did that happen? I then just pulled out the database code and fetched the comic every time, and it worked. So my first guess was there was something wrong with the database. But why did it suddenly show up? So it comes to the next question. Oh, not yet. Yeah. So my first guess was it was database failure. Like I just moved it to a new host, and I went heat and I used deprecated backend. Or it's deprecated now. It wasn't. It was also deprecated at the time, but I was running an old version called MDBX, and I moved it to FreeBSD, and stuff kind of sometimes work on FreeBSD. So I thought that was maybe an issue, but that didn't really end up being a thing. I tried to use a hash map or something, and it still happened. So then I asked myself, what changed recently? But how recently was the question? Because around 2 years before this, a friend has been hosting the bot, and I hadn't really been updating it much because I didn't need to add in features. So it has been hosted in Florida, and last year there was a hurricane. So we thought last time there was a hurricane, the power went out in the area where the server was hosted. So we thought, let's move it this time, in a good time. So I look back to the Git log, and about 6 months before this failure, there was a commit that changed. It says, use ears instead of time. So that comes to the interlude, what is a date? So I will be looking at 2 datetime libraries, looking at time, which is one of the big one everyone knows, and ears, which is a smaller one that nearly no one knows. So a date in time is a packed U32 that is doing some fancy stuff with bits and stuff. Like it has 21 bits for year, but it only uses 15. For some reason, I think it's some optimization. And then it has an ordinal that is the day of the year and stuff like that. If you take a duration in time, it looks like this. This could as well be the duration in the standard library. They have exactly the same definition, even down to nanoseconds having this, so you can do some niche optimization on it. That looks quite normal. And my key generating code to get the date was taking the time between the comic date. I can also fetch older comics, so it is the comic date for some comic and then the Garfield epoch, and see how many whole days there are between them. And that works out fine. So let's move up to ears. Ears works in a different way, just have years, months, and days. This is also how GIF works. So much of what I say about ears also works for GIF as well. So an interval in ears is months and days and microseconds. So that works a bit differently. So the key. So I had done this. I rewrote it, and I'd only run it and tested it a bit, and it seems to work. This is the key generating code. So it says comic date minus Garfield epoch dot days. That seems pretty reasonable, right? Except it isn't. You might be able to see the error here, but yeah. So the dice that day, I pretty much rolled a critical failure. So between the start of Garfield epoch and 9/11, there's 23 days, 2 months, and 23 years. Between Garfield epoch and 2024, October the 12th, there is 23 days, 3 months, and 46 years. That meant that these 2 values stored in under the same key, which that is maybe a bit of an issue if you do it. So the bug was to change to use days since, which just does the same as that. So why did this happen? So one of the things with ears is that it's pretty much in development, a bit at least, and I'm pretty much the only one who uses it. I think I haven't met anyone else at least. It didn't have a day since operator, so I just looked through the documentation a bit fast, and I saw days. That seems pretty reasonable, so I just used that. But that, of course, just takes the days part of the whole interval. So what is the moral of the story? Like the moral of the story is probably to read the docs, because the docs are very clear about this and say it very nicely that this is the day's path, and you shouldn't expect it to be the other thing. Like both the ES docs and the GIF docs are very clear about this. And the other model is probably you should test stuff. So I did this talk a few months back in Denmark, and also had this test, but I didn't have any test. So I wrote a test now. So this test is we look through like I think I set it to until the year 3000 or something. Yeah, until the year 3000, and see if there's any key collisions. This test might look slow, but there's only 300,000 days, so it runs in like around a second without optimizations. So that is the main thing you should get from this. There's also a bit about. So I don't have a slide with this, but so another thing at least I got out from this was so the first thing I did on the day that happened, it got fixed in a couple of hours. Like I found the bug and I ripped out the comic, or I didn't find the bug, but I ripped out the database code in around an hour or something because it was a Saturday and I wasn't doing anything else. So one of the first things I did was I sat down and I began to write like a post-mortem because I thought, why not? It might be fun. That was pretty much the only reason. But when you write down what happened, like you have timestamps, like pretty professional post-mortem. So I had timestamps. I had cause, and I had one like a section I also think is why did it happen? Like so. It's something that is good to question yourself when you have like a big bug. Maybe just like write down a few words about how could you do it. You don't need like how could it happen and how can you make sure it doesn't happen in the future. Like you don't need to put blame on anything. I think if you put blame on anyone or something, I think it diminishes the usage of it. But if you can just like write down how you can be sure that it doesn't happen in the future, that's a good idea, and it's something you can look back on and say it. Like I had another, so I wrote another post-mortem like a few months back. So Go Comics, they changed the whole website and. So instead of like before, I was just taking the open graph tag as the image link. That was the easiest part. But now I had to traverse the whole HTML, and they also made it so that was okay. Traversing HTML is not too bad in Rust if you use something like LOL HTML, which is it's a good grade by Cloudflare. I think have that one. But the thing is, they also changed it such that if you didn't write or if you wrote the comment date at the end of the URL, as I did before, you would get redirected to the site without the dates in the end, because the comment date is always just without the thing in the end. That meant that. Because my clock is not synchronized with the clock of Go Comics, even though I use Indianapolis time. Go Comic apparently don't for Garfield for some reason. I would sometimes miss the correct date. So I had another issue where I would post the comic for the day before if somebody had requested the comic earlier that day, because then I already had fetched it. In the time, I think it was like between 2 and 7 in the morning, or 3 and 7 in the morning, European time, and that was also an issue. So I then had to read the date on the page and stuff like that. So, but there I also just wrote a post-mortem just because it's only for myself. Like I don't expect anyone to read them, but I think it's just nice to have something to look back on, and you can remember it by doing something really stupid. But yeah, I think that's all I have to say for this.
Thank you very much. Amazing. Alrighty. So, do we have some questions? Let's see if there are a couple of hands raised. Terz, just in front.
First of all, I was wondering, what is the CVE score for this bug?
Probably around 0 to 1, I think. Yeah.
Okay. And my second question is, why do you use EOS instead of some of the more established grades like Chrono and Time?
Because I'm a bit of a hipster, I guess. I was never really a big fan of Time, and I was even less a fan of Chrono. And then EOS came along. It was before GIF was around. I would probably use GIF now, but EOS, it has a pretty nice time zone integration that at least in my opinion, the other ones lacked at the time. And then I could set it. I wanted to be in Indianapolis time because that is where PowerSync is located. That's where Garfield is from, in the lore, of course. So that was the reason I used EOS. I don't really have a better one. I also know the guy who develops is someone I know, so that was also a bit of a contributing factor.
All right, thank you.
Right. Some questions in the middle of the room, over there. Right.
Yeah, I feel like this problem would have been solved if there was like a production-ready crate that used the Garfield epoch as the underlying date representation. Do you know if this gap has been closed since this bug occurred? Or?
I don't think it has. So when I did this talk in Copenhagen, I looked through a lot of date time crates, and they all do it in different ways. Like, most use the Gregorian calendar, but then they turn it into the Julian calendar when they do date calculations and stuff like that. But none of them have decided that. I think so. EOS, I think, turns it into Unix time instead of Garfield time, of course. But like that's a good tip if you are running a 32-bit system and you're like, I need 8 more years. Then you can change to Garfield time.
Cool. Did you see it back there? All right, cool.
Well, it was pretty funny that, well, to me, it was pretty funny that 9/11 was the date that it stopped working or that it broke, but I don't really understand why.
So, okay.
What exactly was the bug? I didn't quite catch that.
So the thing is, I take these dates and I store them into my database, and because people are macabre, I guess, they look up comics in the past, and one of the most looked up dates are 9/11. It's not a really interesting comic or anything. It's more just the date. Like people want to look up what happened, what Garfield comic was that date. That is one of the other features. You can look up a comic for any date. So people just look up 9/11. That is, I think it was like 9/11 and the day after was the most looked up comic by far, when I had some statistics for it years ago.
Bit strange, I guess.
Yeah.
But okay, pretty funny.
Anybody else? More questions? In the front row again. Next one needs to be at the back of the room. So.
Oh no. So, in your professional opinion, what is the best Garfield comic?
I can't remember the dates, but there was a series, I think it was last year, of 5 comics that all ended in Garfield waking up in sweat from his first nightmare. And I think those are some of the best Garfield comics in a long time. And that's probably my favorite series of all time. And,
so what you're saying is, what I'm hearing is Garfield is still getting better. Last year's at the top of all time.
It's a bit up and down. Some days are really bad, but there are some good comics every now and then.
I can concur. It was a really great series. Right. More questions? Yeah.
Do you have those stickers available anywhere? Because I would love one.
I have some in my backpack. So catch me and you can probably get some.
So good stuff. Any more questions? Over there again.
How did you get into the Garfield ecosystem?
Okay, that's a bit of a longer story. So one of the first Rust projects I got involved with was a project called Serenity, that is a Discord bot framework. I got into it to make a AOE taunt bot, but that's another story. So I thought, let's at that time I found out that Garfield comic still comes out every day and you can get it on the internet, and I thought, let me make a bot on it. And I made a bot in Serenity, and then some years pass and I get involved in a new Discord bot framework, and then I moved Garfield bot to that framework. It's called Trilight. It's a really good project. Use that. And I used, at least for a long time, I just ran the latest and maybe greatest software for Trilight, and I tested it on my own bot for a long time because I just needed a place to test it, and I like Garfield, so yeah. I think there's like, I think the bot is in around 1,500 servers, and there's like 200 that subscribes to it, but Discord stopped giving me those numbers, so I don't really know anymore.
Right. I could listen to the story the entire day, but I think we're already into the break. So if you have any more questions for Waldemar around Garfield Epoch, the entire Garfield ecosystem, or if you want to do a Garfield Epoch Con at some point in time together with him, I'm sure he's here for the rest of the day, so catch up with him. Thank you very much for this talk. Give another round of applause to Waldemar. Excellent. So, and we are now entering the last bigger break. So the conference resumes at 4:20 with the last talks of the day with Victor and Elise here in the main room. And this was it for me. So thank you for being with me, and see you around.
to get ready? We'll sit over there then. Will you have enough time for questions?
I think so, yeah. Okay. I can always defer for the breaks.
All right. We're back for the final block. Some quick announcements before we get started. First announcement, the wrap-up is here in this room. So even if you go to the other talk after this talk, make sure to come back for the final closing event, for the final closing talk. It will be in this room. Secondly, we would like to thank two more sponsors of the event. One would be Google and the other one would be FutureWhy. They sponsor the Unconference. So thanks to the sponsors. Why do Rust developers have so few friends? They moved. And with that, it's a nice segue into the next talk, because we will talk about the intersection between C++ and Rust. We have someone here who's really famous, really seasoned developer. He has been a C++ developer for, I think, the most part of 20 years. And he also has recently been a guest in the Rust in Production podcast. Greetings from Simon. He had a good laugh while editing because you were really brutally honest at times, and it was really cool to hear that. I think that's really refreshing. So thanks a lot for having you here. Victor Chura. And just one more note. Victor is a technical lead for the Rust program in the Microsoft Dev division. And with this, go take it away.
Thanks. All right. Am I up? Yep. All good. Thanks for coming. How did you enjoy the conference so far? Yeah, that's the spirit. Last stretch, folks. So I hope you enjoy this last few sessions, and do hang out if you don't have like travel commitments already. Try to hang out for the after conference events as well. I think the social part is actually the most fun part, not the talks themselves, because you can always catch those online. So just like to make sure you're fully awake, pop quiz. Like room is full of Rustaceans, so I expect you to be able to identify some of these species, right? Don't worry. Who thinks these are crabs, by the way? You detected the trick question, right? Who knows what carcinization is? A few hands. Cool, cool. So it's a form of convergent evolution in which non-crab crustaceans evolve into like crab-like setup. And it's sort of, it was coined as the many attempts of nature to evolve a crab, right? So I think this is very suiting for the kind of talk we're going to have right now, where we're going to be sort of at the boundaries of what's acceptable and, between C++ and Rust. So let's get on with it. So who thinks interop is about CFFI? Right. About glue code that we love to write. About code generators. They're trying to see the hands. Fat compilers. What the hell does that guy mean by fat compilers, right? Linkers. Few shy hands. More hands. Oh. ABI compatibility. Few sad hands. Yes, like I saw a guy like there, like. like almost like admitting to something. Anyway, so when you ask people about Rust interop, they usually come up with these sort of keywords that they had sort of felt in the past, maybe in a violent way. So they will tell you about some of their, I don't know, favorite tools to achieve this. Many of them work for what you need, right? So again, not here to sell any snake oil. I'm not involved with any of these tools. If it works, if any of those works for you, perfect. But they all sort of come with requirements, scaffolding needed, sometimes unsafe, dealing with callbacks, allocators is a mess, pinning some all over the place in some cases. Some of them are intentionally opinionated and restrictive in what they cover. They lack core functionality. Sometimes performance is an issue with some of them, and definitely ergonomics is an issue with many of them, right? So each one tries to solve a problem and sort of stumbles in another way, right? So again, when you ask people, they will tell you about source annotations, they will tell you about code generators, about definition languages, some kind of metadata that you require. They will talk your ears off about mapping language semantics and how to deal with various constructs on the C++ side, on Rust side, and so on. So they're all good. They're all necessary discussions, right? And I think the reason why it's so balkanized, so ununiform as a situation is because of extreme range of operation, where both Rust and C++ live, right? And if I look internally and how we use Rust, these are just some of the projects that are public, but many more that are sort of in the works, spanning from embedded things to services and applications and all sorts of things. So it's very diverse. And again, when you talk in terms of what's your project requirement in terms of interop with C++ or C# or other things, people will tell you very, very different requirements. Of course, there are things in common, and of course, as we do it and we sort of put Rust in production, we discover more things, right? We improve the developer tooling. So my team specifically is chartered with improving Rust developer tooling for internal needs, mostly at this point, and making sure this transition is smooth, coming from C or C++, even from C# to Rust. Because these sort of things then don't happen in isolation. They happen in some context, right? Very few projects are sort of completely in a bubble. So we learn by doing, right? We measure impact on security, operation costs. We gain experience with each such experiment we do, from proof of concepts up to production projects. We evaluate costs of porting, of writing new components in Rust. We constantly work to improve the end-to-end pipeline of Rust tooling at Microsoft, right? Everything it takes, not just writing the component and building the component, but what it takes to make it be a part of the engineering systems and quality gates and compliance gates that we have in the company. So sort of make sure Rust is at the right place where we expect it to be. It's no longer sort of a hobby thing, right? It needs to be up there with C++. And truly, developers have this expectation at this point. So it's no longer sort of an enthusiast's game. Again, challenges around debugging hybrid binaries, what are performance targets for these hybrid projects, cross-language optimizations on opportunities, and of course, costs of maintaining these hybrid code bases. These are sort of a new thing. And we need to learn how to build such engineering systems. So I think Rust and C++ are here to stay for a long time together. And having seamless interop between C++ and Rust components is essential for the success of this symbiosis, right? And there are many, many challenges. I'm going to highlight a bunch of them, but there are many more. And we discover more as we build more complex things, right? So in terms of interop, of course, there's many requirements, right? So just to name a couple, of course, people don't want to pay for performance overhead for this interop, right? Nobody likes boilerplate redeclarations, annotations all over the place, right? They want broad type support with safety. You want to avoid lowering through CFFI if possible, right? You want to keep the semantics of higher level abstraction. Ergonomics with safety, so you don't want to sacrifice safety or performance for ergonomics. Sometimes it's a dial. You want it to work with dynamic libraries, right? And all the weirdnesses that come out of that, and all the DLL madness that is on Windows. You want to play well with C++ ABI. And you want to easily automate this thing. You want to easily debug these hybrid beasts. And of course, I'm not even going to talk about build systems, but this is sort of an important backbone of getting stuff done. Just building it on your laptop is not enough, right? So it's a mix of multiple ingredients to make this story work, right? From compilers, debuggers, linkers, interop support libraries, build systems, API guarantees, and so on. So it's a big story, right? It's not something that you can easily solve quickly. And I think we need to learn as a community, not just big tech in industry. And as a community, we need to sort of discover these things and learn from them. So this is just first part of a long journey of learning and discovering what we need to do there. So expect to see more stories and check-ins from this story. So if you want to sort of shout at me, these are the places where you can usually find me and some of the projects where I've done damage in the past. Just to preface here, because I do represent a company, but what I say here, generally they tend to be hot takes. One CVP once told me that I tend to be spicy. I don't know what the hell that means, but it's just, I don't represent my employer. Anyway, so today, a quick teaser, because we have limited time together. But we will chat afterwards, as long as you want. I'll be around, so corner me. So a quick teaser about ABI and layout, move semantics, and CodeGen and compilers. So let me start with a cautionary tale. And that was in my hometown of Prague, right before the pandemic, February 2020. When the C++ committee took a series of polls whether or not to break ABI officially or commit or not commit to ABI in any way. And they decided to pretty much ignore the problem. Few links here. By the way, slides are peppered with links, so if you want to get them later and sort of dig on your own, feel free to do so. So I think we need to look at the C++ story and see how we can deal with this, and also see what we can learn from the C++ story. Because definitely C++ is a sort of king of mistakes and being stubborn about them. So C++ does not have an ABI resilience model, so officially no ABI story, officially. The C++ committee will strongly consider read as reject proposals that could break ABI for existing components. And of course, no official commitments around ABI stability. But in reality, all implementers sort of stick to not breaking ABI for their clients for obvious reasons, right? They don't want to upset customers. And we've done mistakes in the past. We've done this, and people have complained massively. So we're kind of stuck somewhere, in denial maybe. So what is ABI anyway? So this is not a property of the programming language. It's more of a property of the system and the platform and the tool chain that you're using. So compilers, for example, determine class layout, which is not portable, really. So all sorts of these things, like size, offsets, alignment, stride, calling conventions, mangling, and so all these things, they all affect how we deal with ABI, and they all affect implicitly how we deal with interop. Why would we want and when would we want ABI stability then? You don't want to shut the door of future compiler and library improvements like we did for C++ standard library, right? Stabilizing ABI too early might miss optimization opportunities, faster implementations, better implementations, and so on. Might miss the boat on sort of doing tricks with structure paddings and all sorts of things that we do under the hood and that we're sort of shackled once we commit to stability, right? So that's why we kind of, in Rust world, we sort of rebelled and said, we don't want to end up like C++, right? So why do you want ABI stability then? And why is it important in the context of interop? Right? When you don't want to share the source code of your library, so you want to deal in binary modules. When you want to use the most recent compiler for your library. When you want libraries compiled with different compiler versions. When you don't want to recompile everything from scratch. And when you can't have full project visibility. When binaries can be shipped, you want to have binaries shipped independently and updated, patched independently. Think about addressing security concerns, right? Patching binaries in production. And multiple programs can share the same library, including the standard library. And when you care about plugins and extensions, dynamically loaded, right? Scary things, right? And of course, interop. This is sort of the mother lode of where this hits. So if you think back, I'm old enough to been there. The sort of grandfather of all interop was COM, right? At least on Windows. I did most of my programming in my early career on Windows. So I've lived through this. And Microsoft has gone through many attempts of doing interop, and sometimes identity crisis in doing so. And it truly was a marvelous design. And it's still used heavily today for interop. Believe it or not, even with Rust. So this is a potential route, but it's definitely not something that everyone can reach for, right? And it's definitely not a modern design. So designing for library evolution is hard because you want to move fast, you want to improve things, but at the same time, you don't want to lose people behind, and you want to keep things working. It's sort of a contract between you and your users. So the idea is to make all promises explicit if you can, right? Delineate what can and cannot change. Provide a performance model that can let you opt out if necessary, right? And indirect, sort of abstract away some of these changes. Be resilient to change. For example, in terms of struct layout, C++ compilers could provide class metadata members with layout metadata. So allow representation of Rust structs fields in C++. And you could retrieve layout via C++ AST or Rust C query APIs and so on. So again, you could involve the compiler in generating the right metadata so that you can build the indirection needed or glue things together when needed and having this layout information available. And of course, you can do that through attributes, through annotations. You could have the compiler synthesize this data for you, right? Things like size, alignment, offsets, overlapping of sub-objects, all the padding tricks required, and so on. So for example, in client code, you would interact through layout metadata. When you want to access a field, you would go through the metadata for the field offset, do the arithmetic necessary to sort of do the indirection to access the field. And when you need to store an instance on the stack, you could read the metadata for the instance and emit the right alloc information to place the object constructed in place on the stack. For library code, when you sort of don't want to pay the indirection cost, right, for internal calls, you could skip these indirections and sort of bypass the offset math, the offset arithmetic needed to access the fields, right? So again, it's about having support for dynamically sized things on the stack. For example, LLVM has this capability already, and for example, Swift takes advantage of this capability in its resilience model. And compilers can use this for ABI stable value types. So you can have a local variable of some struct defined in an ABI stable library, and dynamic allocs can handle this nicely with very minimal performance impact. Problem is that this sort of doesn't sort of clashes with the C++ idea of size and a line of being sort of runtime values. So you want to have this capability at compile time, if possible. So that's why we need strong compiler ties here to help with this story and avoid the user sort of intervening and annotating all over the place. So you want sort of compiler capabilities, compiler help in this regard, so you can do this very left in the process rather than at runtime, like Swift does, for example. So you could build interop domains based on this idea, modeling boundaries between software modules that evolve separately or together. And you can introduce interactions across separately evolved modules and optimize the way indirection within modules that are always compiled together. Sort of like this would be sort of a simplified picture of the idea. And of course, there's always going to be a struggle between optimization and resilience. So when you want to cross a resilience domain or when you're within it, and how you can be clever about these things so you don't pay the cost when you don't need it, right? Sorry, not sorry. So the status quo for Rust is fake it till you make it, as I call it. Using C calling convention for function definitions and calls, C data layout for type, definitions, and so on, limited to C types mostly, no slices, no sort of nice things. So stability without nice things, right? Sort of like the political scene right now. But we can imagine a better future, a future where you could have stable calling convention that supports common data types that people expect, like slices. Standard data layout that supports enums with payload, right? And of course, layout guarantees for common vocabulary types, like option and result, right? What would you do without these essential vocabulary types? And mechanisms for exporting, importing, naming symbols, working with dynamic libraries, why not, right? So if we're sort of in wish mode, why not wish big? And standard data layout for dynamic trait objects, why not? Way of dealing with types that depend on global state, like allocators, stable type ID, and many other good things that we sort of have grown accustomed to. And we don't want to give these up just because we need to interop. And of course, I would say the biggest challenge here is not just making things work now, is having the right engineering systems in place to detect when these things break and help with maintaining them, right? Either enforce them through the compilation model or have appropriate tooling to detect and warn us when these things don't align. So I have a scene here to set up for you. It would have been great if I would have like some real actors, but I'll read it. So conversation between Captain Picard and an alien. So the teleporter, how does it work? Asks the alien. Well, it beams people and arbitrary matter from one place to another. So alien, is it safe? Picard, yes, but the earlier models were a hassle. They'd clone the person to another location, then the teleporting chief would have to shoot the original. Ask O'Brien, he was an intern in those times. Bloody mess that was. So I have to talk about object relocation, sorry. So this is a particular sensitive topic about handling C++ values. And in general, they tend to be conservatively considered non-relocatable. In contrast, a relocatable value would preserve its invariant, even if the bits are moved arbitrarily in memory someplace else. Think about an integer, right? Moving the bits of an integer in another location in memory would preserve its value, right? The bit representation is the whole value type. I have a whole other talk about objects in memory and regular types. So C++ assumption of non-relocatable values actually hurts everyone for the benefit of a few questionable designs. And only a minority of objects are genuinely non-relocatable. Of course, we could definitely painfully know that, but we tend to be conservative in general and just claim that nothing is relocatable. There's a paper for that in the works for C++ 26. To safely relocate objects in memory. I put a link there, only has 46 pages, so go ahead and read it. But if you don't have the patience, I have summarized it here for you. So many types in C++ cannot be trivially moved or destroyed, but do support trivially moving object to another location by copying its bits, also known as relocation. Sometimes even support bitwise swapping, right, without violating object invariants. And of course, the reality is that optimizing containers and implementations in the industry already make use of these tricks, but technically they're undefined behavior from the language point of view. So the spirit of the paper is to legitimize some of the existing practice. There are many sort of details here. I'm not trying to sort of gloss over them. It's not a simple subject. Very well-known book about move semantics in C++ has over 200 pages. Anyway, currently you cannot place a C++ object on the Rust stack since it cannot be safely mem-copied moved, so relocated. So this proposal would make C++ types trivially relocatable through annotation, for example. And if you can get most of the standard library to be relocatable, that would allow most C++ types and, of course, later user types on the Rust stack. And that will improve how you do efficient interop. And of course, support for destructive move in C++ would very much match the behavior of Rust drop mechanics, right? For example, in Rust, the move is a blind mem copy, and you render the move from object inaccessible, whereas in C++, it's like a mutating clone operation, and you leave the moved from value accessible to be destroyed at the end of scope, and even reassignable. There's a crate for that, by the way. I don't know if did anyone use the move it crate? I see just one hand, two hands, two shy hands. Okay. Okay, so I want to sort of close with a more delicate part here, and that is compilers' involvement in interop. And many of these tricks that I talked about do require deep compiler involvement. On the C++ side, there's like multiple choices. On the Rust side, it could be easier. So when we talk about high fidelity language semantics and mapping these vocabulary types and semantics from one language to another, and when you want to have this be efficient and have good coverage of the language and types and the standard library and all the sort of intricacies of each language. And think about C++ semantics is much more complicated and larger than Rust semantics. You need front-end involvement in some way on the C++ side and on the Rust side, right? And ideally, on the C++ side, you want to have a toolchain independent IR representation in the interop tooling so that you're not tied to a specific toolchain. Sure, you might only care about a particular toolchain, but if you don't, you want at least the tooling to be flexible, not lock you in. And you will probably need some support libraries to have the right sort of type constructors. On binary level fidelity and ABI even, and linking and dealing with dynamic libraries, you want to have good platform integration. You want to play nice with post-build tooling and fit in the ecosystem, sort of meet C++ where it is when you come with Rust, right? Rust is the newcomer, right? So it needs to fit in the platform, it needs to fit in the ecosystem, in the components it interacts with, in the infrastructure and engineering systems it deals with. So then you need to have proper code gen support and integration in sort of the compiler backend. Make sure that the C++ and the Rust you generate and the debug information you generate makes for a coherent story without any sort of glitches. And the hybrid components you get, the hybrid binaries you get, have the right debug information and the right code layout and work well with the existing ecosystem of other libraries and tools that sort of make assumptions about those binaries. And most commonly, those assumptions are, these are C++ binaries, right? So that's why I'm saying it's a very broad story here. It's not a story just about some interop crate. It's not a story about just emitting some glue code and just have the compilers bash at it. It's a more orchestrated dance on both sides, if you really want to make it work. So this year has been sort of exciting in this space. Very, very lively talks in Rust project and the community, and even in the industry about the interop context in general. Mostly C++, but in general. And of course, this is also a part of the Rust project goals. It's a specific goal that's been set out for this year. I'm super happy that the Rust Foundation actually joined the C++ ISO committee, and we have people sort of attending on that side. Thanks, John, for getting involved. And sort of short term, the idea is to contribute some engineering time to the key interop crates out there, sort of help people with where they are. But long term, we want to sort of evaluate better approaches to seamless interop between C++ and Rust, and facilitate discussions so that we figure out the solutions that work well across the industry, across tool chains, across problem domains. And ideally, if we can find the right abstractions for many other language interops, not just for C++. There have been one significant meeting on this topic in February, and one very short brief sync in April. I have linked the notes there if you're interested. And if you care about these things, do get involved in the Zulip interop channel. I've linked it there. You can easily find it. You'll find many people that you know there, both from the Rust and C++ side. And the next meetings on the topic will actually be here in Utrecht at the end of this week at the Rust Project All Hands. There are going to be specific study groups for C++ interop. So I'm really looking forward to the discussions happening there. So I think with time, I'm almost time or none, but but I'm open for discussion. And if we don't have time on record, please corner me and ask me stuff. I'm super excited to learn from you and how you deal with these things, and what you think are the best ideas to solve these challenging issues. And teaser, sort of next episode. That's it.
All right, thank you, Victor. We have time for one question only, because we're running short on time, so whoever shouts C++ the fastest gets the microphone.
It's dangerous.
Okay, so doesn't look like there are any questions. I guess that's a good sign, because then everything was on the slides. You know how to find Victor?
Oh, that's a scary sign. No?
Or is there anyone? Looks good.
I can't see anything.
There we go.
Light is red.
I had one question. If coordinating with the C++ community doesn't go well, how hard do you think it would be for Rust or Rust-C to try to compile C++ itself?
You don't know what you're wishing for there.
I think I do.
No. So, that's a world of pain. So no, I very much believe that the C++ folks are interested in having a good solution here. They're genuinely interested. And as proof, there are many C++ folks here this week joining the Rust project All Hands to discuss interop issues. Some of them are on site, or they will be towards the end of this week, like from tomorrow. And some of them are joining remotely as well. Significant people from the C++ committee are interested in this topic. Either personally, they want to have a better story, or they've been chartered by their companies to find a solution here. So I think very much they're interested. Now, the solution might not be pleasant for everyone, right? That's why we need to have these discussions. I don't think there's an outcome where we're going to say, oh, we're going to end up on a solution that is going to make Rust people happy and C++ people angry, or the other way around. That's not going to be where we end up. But I see genuine interest on both sides to make this happen. So I'm optimistic. The idea of just like forget about the other side, we'll make it happen, I don't think it's going to be a recipe for success. And we need to succeed together, because we're going to be stuck together for many years.
I think that's a very refreshing take. Thanks a lot for taking time, Victor. Thanks for the talk. And as always, we do some quick reshuffling here as we prepare for the next talk. If you were about to leave this room, make sure to come back for the final closing session, which happens here. pronouns are Sushi. All right, we're about to continue. During the break, someone approached me and said they really liked the Rust jokes. Unfortunately, I ran out of them. I had one about results, but it was just okay. Actually, I have one more, okay? This is the final one for today. A son comes to his dad and asks, hey Dad, why is my sister called Rose? And he says, like, your mother, she really likes roses. And then the son says, thanks, Dad. And Dad says, yeah, but why do you ask Rust enums? Yeah. So our next speaker, which is also the last speaker of today's main track, is Alice Cecile. You might know her from the weekly Bevy merch train. She writes that, and also she's a technical project manager for Bevy, and she also founded Leafwing Studios with our other speaker, Rose Peck. And yeah, give it up for Alice.
Hi, everybody. I'm Alice, and these days my full-time job is to make Bevy, which is beyond exciting. Bevy, if you haven't heard of it, is I would describe it as a next-generation open-source game engine made in Rust. Okay, there we go. So before I begin, I'm giving this talk, and you might think that this was all my work. This was Alice is a solitary genius who slaved away and invented this, but that's really not true. This, like pretty much everything that we do at Bevy, was a group effort. I'm just here on the stage telling our story. So this idea of immutable components was something that has been independently requested and independently reinvented by a huge number of just random users, people like you, who was like, hey, wouldn't it be neat if we could do this thing? But I tracked it down and I tried to capture kind of the timeline of what happened. So way back in 2021, back when I was first getting involved with Bevy and when I was, first learning to program, first learning to write Rust, I got really annoyed about how hard it was to use indexes in Bevy. Something like you have a quad tree and you want to track where your positions are, and then you want to quickly look it up. And if you've ever used indexes before in a relational database or anything, you know that keeping them up to sync is a pain in the ass. And I went through a half dozen different solutions, and I walked away very unsatisfied with how hard it is to keep these things synchronized. A couple months later, I was talking with Boxy, who you guys may also know as now a Rust project contributor. She was talking, and they idly proposed that you could use the component trait, and you could just set a constant Boolean or whatever to control whether or not a component was immutable. There wasn't like a lot of thought about like this would be cool for X and Y reasons, but like, hey, you could do that. So in 2023, we stole a really cool feature from one of our main competitors and beloved colleague, Flex, which is a C and C++ ECS. And that was component lifecycle hooks, which we'll talk about later because they become very relevant. In 2024, another contributor, Naked Edible, explained how you could use the immutable components and hooks together to keep our entity hierarchy consistent, because we had constant issues with this getting out of sync, and then this causing undefined behavior because we were relying on the assumption that it was correct in order to make things faster, as one does in game dev. And that to me was like kind of the core moment for this pattern. That's the heart of this design. Shortly afterwards, I came to the realization one day as I was reading our Discord of, oh my god, this solves the indexing problem. And not long after that, one of our contributors, Bushrat, down in Tasmania, said, "Hey, I'm going to actually go and implement this feature," and it was fantastic, and it went actually quite smoothly. In January of this year, Kurt came down from his cave and took a look at what we had made and said, "Oh wow, this is really cool," and then we wrote a relations implementation using it, which was long overdue and very, very much appreciated. And finally here in May, I'm here on stage talking to you guys about it. So what I'm here to do today is basically to share a fun story with you. Most of you guys don't use Bevy. Most of you guys, well, I mean, maybe who here uses Bevy? Let me see. Okay, so maybe like half of you guys use Bevy. I take it back. Thank you guys for coming, and next time I give a talk, I want to see every hand in that audience raised. But why I'm here today isn't to talk about this feature necessarily. It's to share a fun story with you and to talk about how we had this niche feature and it had a stupid bug, and that bug turned out to be actually really useful. So we didn't fix it. And there's a couple of broader lessons about programming and more important patterns, but mostly you're here to hear a fun story because I love this. So that feature that we're talking about that had this bug that turned into a feature is immutable components. This idea that you could somehow prevent users from mutating data while it's inside of the ECS. You say, no, you can look, but you can't touch, which is a very rusty idea. So if you've never used an ECS before, if you've never used Bevy before, let's give you a quick rundown of how things work, and I'll tell you some pretty little lies about what an ECS is and how they work. So all of the data in Bevy is stored inside of the ECS. The ECS and the world is basically a columnar data store. It's not actually a columnar data store, but you can think of it like a spreadsheet. And the entity that things are associated with is their row. It's their unique identifier, and the components are like columns. And then you have systems which run periodically, or whenever you tell them to, saying, please read from these columns and select from, filter, join, whatever, and then update the values as I tell you to using normal Rust code. And for the purpose of this talk, the component part is the most important thing to focus on. If you have data of any type that implements the component trait, you can store it inside of the ECS. And each component is stored on a specific entity. Then once you have it in the world, you can query it and you can access it and you can mutate it in whatever way you so please. So if we have a little code example here, you start off by defining a life component. You create a world. You spawn an entity. You insert the component onto that entity, and then you can actually access that component for that specific entity, and you mutate it and read it, and you do things like assertions. Very, very straightforward, except for the fact that it's all type erased. So when you're programming, it's really common to want to carefully control how things are accessed. And the most common way to do that is with the getter setter pattern, where you say, okay, we have some struct. The struct itself is public. Its fields are private, and then you have public accessors and setters, right? And you say, okay, you can read however you want, but when you set it, we're going to go and check that some things are correct, or we're going to correct them for you, and therefore make sure that the invariants, the internal rules for your data don't get screwed up, which is very nice for programming at scale and avoiding bugs. Immutable components were kind of inspired by that same impulse of like, what if we could restrict what people were doing in order to avoid these sort of stupid mistakes and to make our APIs more misuse resistant? It's a reasonable enough little request. You go and you make an ECS flavored variant of the getter setter pattern, and where you kind of tie into Rust memory model around the biochecker and the distinction between immutable and immutable access, and everything is lovely. It's not earth shattering, but it's I mean, sure, we may as well, I guess. So to understand kind of how you might implement that, let's take a look at a slightly simplified, only slightly simplified version of our component trait. So we have send plus sync plus static. You guys love it. The send plus sync plus static bounds, and it's send and sync, so you can send the data across threads, and it's static, so then you can get the type ID out. And it's just a trait, and you just implement it. Very, very easy. We have a derive macro to make this even easier. And then when you're calling getMute on it, you have a C to component bound, so then you can only get components out, so then you know how to access them properly, and so on. But if we take a look at how it might change, we can see that it gets a little fancier, but it's really not too bad. So you now have an associated type. We love associated types over in Bevy. Associated type mutability, and anything that fulfills this must implement the component mutability trait, which in Bevy is a sealed trait. You have mutable and immutable. You get to pick one. Then we implement it, and then all that changes is during the trait bound, during the getMute signature, we restrict it to mutability equals mutable. And so if mutability is not mutable, you can't call getMute on it. Ta-da! It's really very simple. And so you see this code where we have this little annotation that says component immutable. That says, hey, please set that associated type to immutable. And then we try to write the code and we call getMute, and it fails to compile. And we get a lovely error message of type mismatch, and where they expected mutable, found immutable. And it's like, that's just the error message out of the box. Very, very lovely, very straightforward. We've done this in a type-safe way. But it comes with a problem. The problem is, well, yes, you can't restrict people from mutating it while it's inside of the ECS. They can just take the data out of the ECS and then mutate it and then put it back in. And that's really not very immutable, you know? Or they could just insert and overwrite a new value, and I mean, you're technically not mutating the same data, but you may as well be. This seems like it could be a problem, right? Like that just kind of shoots a hole in the feature. We're offering these guarantees, these promises to the user, and saying, I mean, it's kind of immutable, but not really. Like if you wanted to have this, if you want to restrict mutability, you might say, okay, let's go and make sure that you don't have any public setters. Make sure, and you're like, okay, no, you have to prevent overwriting, so you can't have any public constructors either. And you're like, oh, okay, no, I'm totally safe now. And then somebody tells you about mem swap, and then you're like, well, fuck. But rather than trying to fix those holes, because as far as I could tell, they're basically unfixable. Maybe this is actually a feature. Maybe this bug that we can't fix is a feature, and so we should proceed with this feature with immutable components anyways. But kind of in order to understand how it might be a feature, we should talk about lifecycle hooks. So lifecycle hooks are things that trigger when your components, when something happens to your components, when they're added, when they're removed, and so on. And these, the really important thing is this can cause arbitrary side effects. It has a left mute world, it goes and it mutates the world immediately in any way that you want in order to do this. And these are designed as kind of like constructors and destructors. They're designed to enforce invariance. And the really cool thing here is when you're using that bug, that immutable components loophole, I guess I'll call it, is whenever you do this, you're inserting and then removing. And that means you are always, when you do it, triggering these lifecycle hooks. And that means you have arbitrary reactions that trigger immediately every time. And that is very, very, very powerful for maintaining invariance. As a bit of an aside, if you've used Bevy, you're like, man, this sounds a lot like change detection. We have this whole feature that we've had since, Bevy 0.3 that I helped design, where you can say, hey, what's changed, and then respond to changes. Why can't we just use change detection? So in order to understand the answer to that, we should take a look at how change detection is implemented. So the basic idea here is we have a mute t smart pointer type, okay? And it dereferences to t, and whenever you have, whenever you change something, the tick inside of it updates, and it says, okay, this is the last time I was changed. And whenever you run a system, it says, this is the last time I was run. And then you compare the change tick to the last time the system ran, and then you say, okay, is this newer or older? And that's great. It's quite efficient. It's very straightforward, and it's very reliable. But the problem here is that it doesn't catch everything. It doesn't catch everything immediately. So the question here is, why do we need both? Why do we want to have both change detection and this immutable components loophole? Why isn't, like, the immutable components loophole allows us to respond to anything arbitrarily immediately, like way, way, way less room for bugs. The problem here is that it's really slow. There are two ways that it's really slow. The first one is that Bevy is fundamentally multi-threaded. Bevy allows you to run multiple systems in parallel simultaneously, each of which are accessing a different part of the world by splitting the borrow. And if you allow them, any arbitrary system, to provide arbitrary side effects that can access any part of the world that it didn't declare access to, you're going to run into problems. And so in an ECS where you didn't do that, you could theoretically do this, but you still wouldn't want to. The core problem here is that there are two different mechanisms to do this sort of events. There are pull-based mechanisms, like change detection, where you're pulling for events and asking, do you have anything new for me? Is there anything that I need to do? And there are push-based mechanisms, like immutable components, where you trigger something and then it propagates downstream and downstream and downstream and downstream until it stops echoing. And each of these have their trade-off. The pull-based mechanisms are much more efficient because you can batch them. And this is one of the core principles of ECS. It's one of the core principles of data-oriented programming. It's one of the core principles of writing code that's fast. Is you need to do similar things together, so then you get better memory locality, and because then you can take a more global view, because then you can use parallelism, all of these things. But pull-based mechanisms have. You have to constantly pull. You say, hey, is there anything for me to do? Is there anything for me to do? And they also take delayed effect, which is a huge problem because it introduces this gap between action and reaction, and in that gap, bugs sneak in. The push-based mechanisms will have higher overhead, but they'll have immediate effect. They won't require any polling, and they are very, very good at leading to arbitrary spaghetti, because you're like, hey, when this thing happens, you should do this other thing. And when this thing happens, you should do this other thing. And it just kind of fragments through your code, which is hard for debugging. So, but as a result, there are times where you might want one, and there are times where you might want the other. And so both of these mechanisms should exist in Bevy. But that notion of closing that gap where the bugs can squeeze in is really, really important, and that's why this immutable component loophole is a big deal. That's why it's so useful. That's why we managed to implement relations with it, because relations, for those of you who don't know, are basically a structure. It's a doubly linked list stored in the ECS, where you have one entity with a component that points to another entity, and then the child entity or so on points back up to its parent. And you can traverse it up and down and so on. And if this gets out of sync, it's very, very horrible. Even if it gets out of sync for a fraction of a frame, you get horrendous bugs, and then you can't. And because you don't have any guarantees here, you can't make unsafe assumptions to make things faster. The other thing you can do is you can use it to implement indexes, which are basically a centralized data store that allow you to say, okay, these components have these values, please look them up quickly. And you can do this to solve that data synchronization problem that I was so upset about way back in 2021. So what's the takeaway here? If you're not using Bevy and you're like, well, that's kind of neat. Like, why did you come to this talk? But also, like, what can you learn and apply to your own programs? So the first one is that push and pull architectures are very different, and they have very different sets of trade-off. And sometimes you want both simultaneously. And when you're thinking about like, how should I respond to events? How should I handle changes? You should think about, do I want this to be push-based or do I want this to be pull-based? And both of them are valuable, but they have different trade-offs. The second one is that try and put flexible side effect systems in places, like where you can just do arbitrary things like as a side effect of when stuff changes or when events occur or so on. It's really, really useful as a powerful tool, but warn your users to use them sparingly because they're slow and confusing. And I think that the rustiest lesson, and the reason why I chose this talk for this venue, is that sometimes by telling people no, by saying, you can't do that because that's not safe, you can get all sorts of powerful new abilities. Thank you.
All right, thanks, Alice, for this wonderful talk. As you can see on the slides, donate to Bevy. If you are a Bevy user, support the ecosystem. It's very important. And now we have some time for questions. Yeah, there was one. Oh. Guess he was just stretching. I think, yeah, there's one here, but I have one already.
Yes.
So, like, from you have a game studio now, like. What is that about?
So Rose and I, we used to have a game studio back when we were more unemployed, and we're like, hey, let's make some video games, and maybe we'll even make some money out of it, and then. We got mostly too employed, but every now and then we're like, maybe we should make video games. Maybe we should sell video games. So right now, and I spent a while working as an indie dev on a Bevy project for a completely different funded studio, and that was a lot of fun. But right now, in case you didn't know, making video games is not a very good way to make money, and you need money to survive. So right now, I have turned into an engine developer. Maybe one day I'll go back to do game dev again, because I really love project management, I really love programming, and I really love game design, and that's something I miss.
And a bit of a follow-up question. Yours is next, but I'm curious. So, what do you think about TinyGlade?
So
they use parts of Bevy, but can you talk about it a bit?
Yeah. So TinyGlade is a really, really cool project and a really beautiful toy. If you guys haven't seen it, it's so cool, and it's incredibly cool that it's written in Rust. It's using a lot of Bevy. They have their own renderer, but they're using the ECS, they're using the input, they're using the windowing, and so on. And then they manage to. So, when you tell people who aren't game devs, oh yeah, they're not using Bevy's renderer, they're like, okay, so it's not like really using Bevy. Like the Bevy must kind of suck. But if you talk to professional game devs about this, they're like, holy shit, you can replace the renderer? But it's I'm not being paid by them. I don't even think they've given us any money. But anyways, it's a fantastic game. It's a delightful little toy. If you guys like cozy, charming experiences, do that. It doesn't have a lot of gameplay, so it's not really for me. But I've messed around with it, and it's such a mastery. Like it's a delight of procedural generation and tech art.
Perfect.
So yeah, Bevy is breaking very often. So let's not talk about stabilization, but what's the next thing that will break?
What's the next thing that we break for Bevy? I think that's probably going to be all of rendering again. Rendering is overdue for a lot of tech cleanup, both in terms of reorganization and in terms of dynamic materials and in terms of maybe overhauling the rendering graph, and in terms of swapping over to Weasel, which is an extension of the WGSL shader language. And yeah, they're going to break stuff again. And my job is to make sure that everything keeps working as best as they can, and that they actually write better migration guides this time.
Hi. Flex was mentioned very briefly in the talk. I understand that's a C++ ECS, but I don't know much about it. Do you think this sort of immutable components thing could be applied in other languages, or is it like a Rust-specific thing?
So this is super easy to do in other languages. You wouldn't use the same mechanisms, obviously, because you don't have traits, but it's at some pretty much no matter what you're doing, you're going to need some way to declare component metadata like this about like, okay, how is it stored, and is it immutable or immutable, or all sorts of interesting properties of components. And in Flex, they actually store this on the entity. They have components as entities where they have each component gets an associated entity, and then the metadata for the component is itself a component. And as a result, you could do it like that. And Bevy will use something similar where it'll have actually, Bevy does use something similar where it has a type erased variant of this for our components, which are dynamic Rust. It's where they are. So Bevy has implemented its own type system. We have runtime types in Bevy, in case you guys ever wanted runtime defined types in Rust. It's kind of as a side effect of what we do. But as a result, we need to support this within there, and so we just have a field on that component metadata that says, is this immutable or not? I've talked with the Flex author about this. I'm like, this is a really cool trick. You should implement it. And he's like, I mean, I guess. So we have to prove him that it's in fact extremely useful.
Hi, Alice. So, considering that now we have relations and observers and hooks and all these things, it continuously feels like all the cool features we wished for in the ECS have already been implemented or are already there. And yet, with newer versions of Bevy, the ECS developers still find new things to work on, and they're always surprising new developments in ECS, even though this is the most mature part of Bevy. So, what is ECS dev up to now, and what are the things coming for the ECS in the future?
Yeah, so ECS devs are a special breed of people who really love who really love arcane type magic and optimization and pie in the sky grand architecture stuff. So, they'll never be done. So, in terms of the most important ECS work that kind of remains outstanding, I would say that generalizing relations to more general non-tree-like relations is the most important. And I have actually planned for this cycle an overhaul of how observers work. I think that they're kind of confusing in terms of API. I think that they're badly documented. I think that the way that they share the same trait as events is kind of stupid. So some moderately breaking changes there to kind of clean stuff up. But in terms of what are people actively working on, there's a bunch of optimization work under the hood to allow you to support large numbers of archetypes, which can be used for all sorts of cursed things. Like people have an idea to implement indexes by assigning each value a unique set of dynamic components via binary bit encoding, and then you get archetypal filters on that. So that, and simultaneously that work would support fragmenting relations, like Sander has been pushing for years. The other work that I think is really interesting within the ECS is there's been work to take out to change how our parallelism works between systems, because previously our parallelism works by fragmenting on the archetypes. So if you have two entities that have different sets of components, they can be parallelized. But computing this was relatively slow, and Bevy's and we ended up with a lot of overhead relative. We were over parallelizing, and so it wasn't efficient. And so we were broadly considering moving towards fragmenting on the parallelizing based on which columns of data, which components they access, which will be much faster to check without losing a whole lot of important parallelization. And in exchange, we can pre-compute our schedule and do things like thread affinity, do things like profile-guided optimization, and so on, that I have always very, very much wanted to do because I think that there's a lot of low-hanging fruit there.
All right, I guess that's about all the time that we have for questions. May I say that in the Rust community, Bevy is a very important component. And with that, give it up for Alice.
All right, sorry, you don't get rid of me, I'm still here. I'd like to ask you to please stay seated for a moment because we are going to have a little closing ceremony in a couple of minutes. We are gathering now everybody from the other rooms in this room. Also, if you are a speaker or a volunteer, please be seated in the front rows of this room because I guess there's something for you. But I guess you have a couple of minutes until the other rooms close. I'm not entirely sure. Do you have any jokes left?
In fact, I tried to make more fun about the Rust compiler, but it didn't allow me. Like it was, yeah. Wait, hold on. How would you say that? It didn't compile. Exactly, it didn't let me. Yeah.
It was nice because when Matthias and I spoke about it yesterday, he basically on the entire way from the conference venue to where we had dinner, he was bringing every joke that he has prepared. So it was so I knew every joke up front. But it was
who's up for contributing to a Rust jokes repo? Raise your hand. Does anyone did anyone think of a joke already? I mean, we can take one or so. If anyone has one. Now is the time to shine. Wait, hold on. The microphone is approaching.
Last night we had hamburgers, and then there was the famous discussion whether a hamburger is a sandwich or not. And then I said, in Rust we have enums, so we don't care. You only care about this when you have inheritance. So maybe with traits.
You need to work on the delivery, but
it was better last night.
The mechanics are there. Shockingly
yeah,
explicit.
For the joke, yeah. Also, can we please have a round of applause for Jonathan, who is throwing this box for the entire day, running around the entire room. It's amazing. If you ever want to join the NBA, I think they have room for you.
So I came up with an async joke, but you'll have to wait, and I'll tell you in the future.
So it's not ready?
Thank you. I tried.
In fact, do we have one more? Yeah, there we go. Can do this all day.
Well, I was trying to make a joke about cargo, but it's not so great.
I was up there.
Actually, I remembered my favorite async joke, which was, knock, knock, race condition, who's there? I also brought it yesterday.
Where do Rustaceans go on vacation? Tokyo.
Any news from the other rooms, by the way?
Running out of material here. Already working through old material now. Yeah. Huh? Oh wow. It's awkward silence.
Yeah. So the thing is, I'm not really good at cracking jokes. I'm just spontaneous, you know. I don't know if I'm always funny, but at least I'm spontaneous.
I mean, it would be easier if it was a C conference, because then you could make a lot of jokes about null pointers. But in Rust, there is none.
Yeah. Oh, okay. Okay.
Feels like battle rap.
Really, no, that was really, really good. I appreciate it. Okay, there comes a couple of volunteers coming in, so if you are a volunteer, please stay seated in the front rows. Okay, now people are coming in, a few of them at least.
Do we have any speakers in the room? You can already position yourself here. Like, we do some compaction in the first row. We do some slab allocation, and they will all be like deallocated. Yeah, at once.
Isn't it an arena allocator then?
Yeah.
Yeah, probably. I'm really not good at that. Okay, now a couple of people coming in. Great. So for everybody who comes in, if you are a volunteer or speaker, please take a seat in the front row or in the front rows. There are a couple of them.
Did I tell you that I wanted to start a Rust meetup in Düsseldorf?
No, cool. Are you still in Düsseldorf?
There were a lot of sign-ups, but eventually everyone dropped. So I will stop now. It doesn't end. No, but there is no Rust meetup in Düsseldorf.
Yeah, there's also no Rust meetup in Linz anymore.
There's not?
Yeah, it's on hiatus. Yeah, I guess we had the last one in January last year or something. So yeah, okay.
I always liked it.
Yeah, of course, sure. For everybody who comes in, if you are a speaker or volunteer, please take seat in the front rows of the room, here at the chairs. If you're not sure if you're a volunteer, you usually have a yellow shirt. They are very easy to spot. Again, for the lot of people coming in, if you are a speaker or volunteer, please take a seat in the very front row. So I guess this is one of the rooms. Who's coming in now? Yeah. And there's plenty of room left upstairs, so distribute yourself, defragment the space. I don't know if defragmentation is still a thing, so I'm old enough to remember it. But also over there on the left side, there are lots of chairs left. Yeah. Cool. Oh yeah, cool. I need to go to FOSDEM then. I've never been actually. All right, fantastic. Lots of people are coming in. Valdemar. So if you are a speaker or volunteer, please take a seat in the front rows of the room. Yeah. How many people are again at Rust Week? A couple of hundred, yeah?
800.
Yeah. Cool. Fantastic. At least it works that you get the people from the other room to this place. This is great. Did Matthias leave already? I was waiting for another joke, but no, he's getting people in. That's cool. Wonderful. So grab a seat, everybody. Lots of room left on the upper left side and upper right side. And again, if you are a speaker or volunteer, please take a seat in the front rows. Cool. It's also great to see how many people were actually here at the conference, because you are always distributed in the area outside, in the reception area, in the free rooms that run in parallel. Lots of stuff going on in the hallway track, in my opinion, still one of the most important tracks at the conference. So seeing everybody come in and being in the same room it's quite cool, actually. Okay, I guess we got one room already moved over here. Okay, this is what they call move semantics. How do you get an entire room to the other one? Mm-hmm.
I think we have 2 rooms.
Hmm?
We should have 2 rooms now.
All right, shall we start?
Yeah.
Okay. Okay, so I'm handing over. All right. So again, for the last time, if you're a volunteer or a speaker, please take a seat in the front row. Otherwise, I have the immense privilege now to announce the very last speaker of today, which is from the organizing team, Terz. Please have a big round of applause.
Thank you. We made it. So we wanted to fill this fantastic room just once more with all of you lovely people. It's so full here right now, and we're so happy that you're all here. Just thank you all for coming. Thank you all for being here. We've worked on this for over a year now, and we couldn't be happier with how it's gone. You can rewatch the live stream if you want, but we're gonna put up specific recordings of each of the talks later. We'll have them edited and stuff, and they'll be put on YouTube, and we'll publish them. We hope to see you at the celebration and the UnConf and all hands. So the celebration, are there still tickets? Yes, there are still tickets. You can still get tickets to the celebration, which is tomorrow. Now do note that all of the other events will not be here. There will be a DUS, but there will be a DUS bus. The DUS bus will go from Jaarbeurs to that venue. So if you want, you can take the bus. You can also just, be Dutch and take a bike. Or, take any other mode of transport that you want. All right, so now I want to thank some people. I want to thank Kinepolis. I want to thank all the catering downside. I want to thank Kinley for doing all of our AV. Most of all, actually, I want to thank all the speakers. They're here in the front. They did such an amazing job. Please give it up for our speakers. I know that I will have, I kind of want to get sick, so I have a full day to just watch all the talks that I had to miss because I had to be here the entire time. Y'all did great. You're all going to get a speaker gift, which will be over there. We're just going to hand that out to you at the end. Right. Of course, also thanks to our sponsors. And I also want to, in particular, call out a few people of the organization, which is Eric, Mara, Laura, Jana, and now I'm really scared that I'm missing somebody, but I think it's just myself left of the organization. They worked so hard, so hard. We had weekly meetings and things. It was tough. We also have so many volunteers, all the ones in yellow. Thanks to our lovely MCs, many of them jumped in at the last second to help us out because we had so many tracks. We needed the MCs for all of them. It was fantastic. So finally, we want to do a little picture with the speakers and also just a picture of the audience. We'll do two sort of pictures in both directions. We'll be doing that in a second. But first of all, I have an announcement to make. We will be doing this again. In fact, we have a date set, 18 till the 22nd of May, 2026, we'll be doing this again. We've already launched a website, 2026.rustweek.org, and if you want to get updates, you should scan this QR code, and then you will get emails about things like CFPs and ticket sales and all of that. So please follow us. And now, I think you all deserve a final round of applause for being here, for being an awesome Rust community, being the awesome Rust contributors, or just community members, or if you're new, you're all so great, and I'd love to see all of you here. Please give it up for yourselves. And now we should have drinks. After the photos. Yeah. Speakers over here? That way.
Okay, so we are blinded again.
Yes. Who's taking the picture?
just applaud you guys and the volunteers. We never got a chance to do that.
Hey, where's the? Oh, we haven't. Who's taking? Who's taking? Should we get? Can you take a picture? Thank you. Okay. Thank you.